Hello future tech leaders, I'm Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
APIs. Again, we have discussed what are the types of APIs we have. So I'm sure you guys have configured APIs, but if you have not, so APIs are something which requires your credentials before you can move in. Like if you get in Google Analytics data in your inbox, you can go ahead and map it as a total connect and schedule it. But when you're doing it as an API, what you need to do is you need to go ahead and configure the APIs by means of the credentials. So what happens? You need to put in the credentials, allow it, and as an option, you can choose the website. Even in Google Analytics, you need to choose the websites, or it is by default as all websites data that you can work with or pull the reports for. A segment is always optional, but you can go ahead and choose your segment in Google Analytics. Initial fetch is nothing but from what time to what time you want to fetch the data in. So note it that you can only process data for the last 90 days in your initial fetch, but definitely the last 90 days, and then however you go forward. You can keep on adding dates and it will be fetched. As an initial fetch, when you're configuring your data, it will be the last 90 days that you get your data. Extended properties, goals, data, events, data pages, etc. Like if you go to Google Analytics and if you check the measurements and dimensions in there, whatever, you can see that there's a specific format in which it is written GA and then semicolon, then pages. So you can add things like that, but in a regular Google Analytics. You will see that it's not a custom. It's like the measurements and dimensions are set. And that's why what they have done is they have given us a Google Analytics custom API. A custom API basically helps us to put in dimensions and measurements of our choice, our needs, and not come up with unnecessary data in my workspace, or like with unnecessary data in my workspace, unnecessary dimensions or unnecessary metrics in my workspace. I don't want it, so what I do is, and also additional metrics and dimensions. There are some of the measurements and dimensions which are not present in the normal API, that is in Google Analytics. So in that case, Google Analytics Custom API helps us in getting all those and retrieve them. So once we have configured our thing, I guess there's a data preview tool. I think that tells that is the answer to the question asked earlier. But in the new format, it's been long that I've seen a data preview for an API because I configure it and go forward and put in a pivot table. So data preview is something that I've not checked for the APIs for long. But then why not check it when it is there? So I see a data preview over here in my slide. So data preview will be there, and you can check how your data is. So yes, so that's how you configure your APIs. Okay, now comes a very important topic called data load rules. Pretty easy topic, but pretty handy, pretty useful. Data load rules is something that you know is that acts as a quick fix for filter between the that acts as a quick filter when we have our data and we need it to be filtered out. Okay, so what is a data load rule? Data load rules are data load rules and applying a data load rule. So data load rule is nothing, but it helps us filter our raw data before it gets uploaded to Datorama. We have talked about it, right? So if we have data from 5 or 6 agencies and we are interested in 2 agencies' data, or we have data for the entire worldwide data and we are interested in all the US and Canada, we need to filter it out as a first hand. Can't we filter when the data is in? Definitely we can, but why do we do it at the first? Because Datorama charges us on a row level basis and we don't want. Like you know from the initial step, it's working with data. It's the initial step whereby you go ahead and filter your data. What you don't want is unnecessarily cluttered data in your workspaces. And what you do is you go ahead and filter your data wherever possible from the initial inception, so that once your data is in, that's basically the cleansed data, or it being a raw data as well. It is the accurate data that you want to work with and that you want to, manipulate, or that you want to harmonize, or that you want to do, and not any redundant data that is going to unnecessarily make your workspace cluttered, right? So how does it work? So you see the data, you see the Excel sheet below, whereby it is said that I want only USA and Canada data to be ingested in Datorama. Correct now? Okay, now in any other case, when you write a logical condition in a logical condition using operators, it will be country equals to USA or country equals to Canada, right? So that will be giving me, when I want data for the two countries. Are we good? Yes, okay, so country equals to US or country equals to Canada is going to give us this thing. So how do we create a data load rule? Let's check it in Datorama. So as I mentioned earlier as well, that whenever you want to have something like, whenever you want to create a data load rule, it has to be always created at first. So by that logic, if we go to data load rules, now that we know that we want the data for the two countries of USA and Canada, what we need to do is if you do it like this, what will happen? Let me delete it. So how you do is you need to go ahead and you can create a load rule. How do you create a load rule? You go to add new. You have to give your load rule a name. There are actions called include rows, delete measurements, and fail the entire rule. So when you include rows, it tells that for this load rule, we need to include these rows which match a certain condition, right? And then there are delete measurements that for this condition, delete all the measurements and keep the dimensions and then fail. The entire load is when you give a certain condition. If that is met, it will never get uploaded in data and it will fail the entire. So for our instance, what we need to do is we need to include the rows for the data set that we were talking about. So there will be a name. So now I want country as my thing, and then I go to the filters and I add a filter. I add a filter and then what happens is these things will come up. So likewise over here, when we have our data and our aim is to get only US and Canada data from among our data sets. So what we will do is we have to write a condition whereby we can use operators. So once we choose the country. So there are the fields that are there. So we have given it a name, right? DLR country. Include rows. Now when we are writing the condition, it is country equals to and country can be not equal. Starts with not. Starts with. Ends with not. Ends with contains. Not contains, it's there. This is you. Then what you need to do is you need to add a filter because you need to. You need to have your data for country equals to Canada, right? So here is your operator of and or whenever there is a condition in which you need to use and or you can go ahead and use it so that multiple conditions are met, right? So once you save it, so this is how it works, and you just go ahead and save it off and you go to your data set. This is a data set that I have already mapped, which basically is nothing but the data that we have. Let me preview the source. So you see, we have date, we have the media by key. We have country as US, Canada, Mexico. We have the city of this and we have impressions. Right. So how do we go about it? We do a next. This gets mapped. So in this data stream I've already created. So I'll be using this. So you remember the number of rows that were there, right? The number of rows that we used. The number of rows that we have. We will need to filter only US and Canada from there. So what we do is we go to edit data stream from data streams. We go to edit data streams and in the rules I'll get the data load rules that I have created for myself. And from here if I choose country, okay, and save it off, it would give me apply only to data going forward existing or apply to all existing. Let me do an apply to all existing and rerun. While your data is rerunning, you can see that here is a pending job that's going on. Okay, successful. And see, the last number of rows that are added has been reduced to 6, correct. So we have 6 rows of data, right, that we want. From the 9 rows, we want 2, 3, 4, 56, 6 rows of data to be processed. As we are US and Canada, to be 6 rows only. Rows have been processed. Okay, next what we need to do? We need to verify it in a paper table. Okay, so we have data for only 6 places. Okay, now comes a condition whereby, so there can be a scenario whereby we have country and city. Okay. So when you have both country and city as a thing, and I say that what I want US, definitely I want US, but I do not want all the cities of US. I want US, but I want this to be only Los Angeles and New York for US. And then I want the for Canada. I want Toronto, and then I want Mexico. I want Mexico and Mexico City and Merida and not Montreal. So in this scenario, what you can do is you can create another load rule. So what happens is a certain thought may come to your mind like the one thought that may come in is, why not create 3 different data load rules? Right? I am understandable, right? You are understanding what I am trying to mean. Right, yeah. Okay, great. So one thought may come to your mind is, why not create multiple data load rules? And when we want to have multiple conditions to be met, right, as in what? Let us create one for US which says that country equals to US and city equals to Los Angeles, or city equals to and city equals to New York, or country equals to Mexico and city equals to Merida, or country equals to Canada and city equals to Toronto. It can come to your mind, but we need to keep in mind something. First thing is we cannot combine our AND and OR operator in data load rule. That is rule number 1. Second is data load rules. Work on a sequential manner. So what I mean by sequential manner is when you create your first rule. In case you are creating a load rule for USSA and city equals to Los Angeles, what happens is when you run your first load rule, what happens is when USA and LA gets filtered, the other data gets lost. So when you are doing the load rule, the first load rule, and you have kept multiple load rules side by side, but as it works sequentially, as you run your US and LA functional function data load rule first, what happens is only that much of the data gets filtered and rest of the data goes for a toss and it is lost. Okay, so we don't have that data anymore with us. That is gone. So when the next thing comes up where country equals to Mexico and city is Merida, when you do that, you don't have any more data left with you. Because the first data load rule has filtered the data for US and Los Angeles and has taken up the entire, and everything goes for a loss. So you cannot do multiple data load rules. Then what then? What we need to do is we need to do a sequential way whereby we need to first filter our countries and then filter our cities, whereby in a logical condition, if you write it will be country equals US and city equals to Los Angeles, or country equals US and city equals New York. But you cannot combine an AND or operator in data load rule. So, but as it is sequential, what you can do is you can filter your country and then you can filter your city. Now in my country, now I need Mexico as well. So what I will do is I will add one more row which calls country equals Mexico and save and in city. We have an operator and then city equals to Los Angeles, Toronto, Mexico City, Merida. And New York by some you know. So you have this cities filtered. Now what you need to do is, as it is a sequential manner, we need to declare the data load rules. You go to your data streams list. You go back to your data load rules, data set, edit. And over here you have country. You also include the city and save. So by the time it gets processed, I hope we are all on the same page, right? We are understanding stuff. And we will move into the next steps of, harmonization. From tomorrow onwards, we will look at the various harmonization factors that are there and we will see how it works. Okay, so it got processed and now, if you see the dataset overhead, the dataset where we have applied. The last set of rows processed previously was 6. This time it is 5. Okay, by some chance. Merida is not recognized by Datorama. I do not know why. I have tried to find the reason as well, but Merida is a city which is not recognized by Datorama in its system. If you guys can find why, it will be more than enough, but then that is not something that we are here for. But we have the 5 things that gets processed 1, 2, 3, 4 and Toronto in 5. Cool, understood. And if you see I said you lied. Mexico DF. I uploaded Mexico as the city, but it translated it as Mexico DF and as it is known in the local thing. What is Mexico DF? I had learned about it earlier. It was something democratic and something like whatever. So it automatically translates the name to Mexico DF whenever we do it. So a paper table is always recommended and you will see along my slides that I've created. Always I have after one exercise or after one calculation, there will be a slide talking about data validation in paper tables because that's the quickest accessible thing that we have with Datorama, which basically allows us to validate our data in a glance at a in your fingertips, you have it. So it will be easy for you to validate. And it's pretty simple because it rests above the data streams. So once you've done one, you can go ahead and do that. So what are the components of paper tables? It has a data range, it has some filters, it has dimensions, it has measurements. So paper tables help us view data in simplified customizable view and paper table is also very necessary when we are working with calculated dimensions and measurements, because calculated dimensions and measurements are not data stream specific, but they are workspace specific calculations that happen. So, whenever we are using a calculated dimension or a measurement alongside a paper table, alongside a data stream, we always need to go and check that if my calculated dimension or measurement is working properly along with my data or not. Okay, so whenever you go to the paper table, you see my paper table. You see the previous year and then you see campaign name, media by name, 6 impressions, whatever you choose. How do you get these? And how do you validate? So you get the holistic view of this in a paper table, whatever we had in Excel. And what helps you is, in an Excel you have the campaign name which you filter. So suppose you want to see a view for a single campaign or something, you can put a filter in there and you can see how things are configured with respect to all the other fields that you have updated. Okay, so create and customize. You go to your analyze and act. You go to paper tables, you do an add new. And you can also go to the paper table. As I was talking, just rests above the data streams. So once your data stream is created, you can go into show in paper table and you can do it. You can customize your dates. You can choose your dimensions. Here it is selected as the dates and then you can choose your measurements as is. So you have the checkboxes of show column total, show rows total. Exactly the same way we have it in the Excel paper table, right? Whenever we do a classic paper table and then we want, not like we don't want our row total or column total to come up and stuffs we make those. And then if you work towards the advanced of it, we call it as a power pivot, and in power pivot we do these changes. So exactly the way a normal paper table works, you customize your dates. And then you go to add filter data stream. So yeah. So how do you add? There is now that you have data in there, you can add a filter. A filter can be of any dimension that is there in your data stream apart from date, because date is already present at the top of the page. And then you can add any of that or any of the filters that are filterable. Rather, it has to be filterable as well. So when I say any dimension, any filterable dimension that makes sense to you to filter and see the data can be filtered from the paper table settings. So once you click on the add filter, you get this filter thing coming up whereby your data stream is already selected. You can go ahead and select any of the campaigns that you want to. So when you choose campaign name, it gives you a space to enter your campaigns. And then you can go ahead and see a filter view. Validate your data using pivot table. So yeah, again there is this campaign name. There are clicks in Excel and you want to validate. If it is being aligned or not. In this example, we do see that it's 1198 was the total and in the pivot table as well. So we can validate that it was uploaded properly. So we can see any harmonizations that went in was for good and it is showing up properly. It's correct impressions again. If you want to choose, you can see that the impressions do match. Okay, So always name your pivot in case you want to refer the pivot for future references. Lastly, it comes a share and export a pivot. So you can go ahead and export a pivot. You can create a widget out of it. So in this view you want as a widget. It looks like this. So this is the table view. How it is. And this is the widget view. Widget is something. Widget is the components that we have for visualization, which we call it as graphs or charts. Those each of them are like called as widgets, and we can also create custom widgets, and a pivot table can also be a part of the widget. Okay, so you can create a report out of it if you want to. If you want to export this, you can create a report out of it and export you can. Like when you create a report, we have seen how we create reports, right? So it's the same way. You can create a report out of this. And you can choose your relevant dimensions and measurements and all the other periodical calculations, and you can export raw. You get the raw view in Excel and stuff. So that's it. I guess it's pretty self-explanatory. Once you have access, you'll get it, and over the course of time as well. When you see me working in the Datorama, you will see that I'm validating in pivot, and it's very self-explanatory piece, and it stays recorded in this call as well. So need not worry about pivot tables much. Okay, now we come to two very important topics in Datorama: calculated dimensions and calculated measurements. Okay, so what are calculated dimensions? How do calculated dimensions vary from classification methods? What would you? Why? When would you use calculated dimensions? And how can you access calculated dimensions in Datorama? So calculated dimensions. So first we have mapping formulas. We have seen mapping formulas when we were adding media cost, or when we are using a callless function. We have seen, like we have used callless function for media by key whenever it was two different column headers in two different formats. So we have seen how callless function works and how callless function is used during mapping. So and in that terms, like you can go ahead and do any sorts of mapping formulas if you have want to. Edit your media cost, like your media cost is coming. You want the media cost column to report media cost into 0.05 for your specific need. You can go and do that. So that is called a mapping formula. Then comes your classification data streams and parent-child data stream. We will do parent-child later. After this, we will do parent-child, because once you know calculated dimensions, I feel Datorama feels parent-child comes first. But what I feel is once you know your calculated dimensions, parent-child is easy. And transformation rules or transformers. There are certain transformation rules or transformers that you can use to harmonize your data. Pretty simple stuff, but important stuff. Now your data has mapping formulas, classification data streams, transformation rules, and all sorts of things. But all these things are coming under the umbrella of calculated dimensions. Because all these are specific to data streams. Right mapping formula is specific to the certain data stream. When you are trying to map your particular raw data to the Datorama model field, in some fields you feel that there is a formula needed and you go ahead and put a formula also. If you want to add a CPC, maybe you can go choose a field called as a media by custom attribute or whatever. From the right side, and in the left side you can have the formula of spend and clicks. But and that works, but that is data stream specific. Parent child is again a data stream specific thing, because whereby what we do is we make one stream as parent and the other as child because we want some kind of harmonization to happen. Data classification, that is again a data stream level thing. Talk about what is not here patterns. That is again a data stream specific, because you need to add data stream as a filter in your patterns to find the pattern of segregated talking about transformers or transformation rules. You will see that your data stream, how it shows the data. It needs transformation of some kind, of transformers of some kind is needed so that you know rows. Maybe you want rows as columns like transposition or cross-tabbing, whereby you do these things. So, but it's pretty data stream specific. Calculated dimension is workspace level. So, if today you make a calculated dimension, that is, suppose you have a placement ID, or if you are aware, if you are much familiar with campaign names. So suppose your campaign names. Fourth position in your campaign name tells you that the country code is present over there. Okay, the fourth position of your campaign name is country. It contains the country codes. If you extract that becomes an individual dimension throughout your workspace. Correct? So anywhere you have this now, it depends that if it is relevant or not. Okay, now it depends that if it is relevant to the data stream or not. That is something that you need to find. If all your if all your campaigns from all your sources have the fourth position of campaign name as country, then the calculated dimension is true for the entire data of your workspace. If your tagging team or if your campaign guys have done their job correctly, then if you make one calculated dimension, it should work across Y. Because everywhere in campaign name, fourth position, if I do an extract function, extract is one function. Extract is one function that we use to extract some part of your dimension. And if I put extract media, extract campaign name, and if I give the delimiter to be say 3 or 4, it will fetch the third or fourth position irrespective of it being used with whatever data stream, because it is at a workspace level. Everywhere you use it, it will be finding the campaign name, classifying the fourth position. That's it for you, okay? So calculated dimensions stand as an umbrella above your data stream filters. So we will read about overarching entities. So calculated dimensions act as an overarching entity. What is an overarching entity? We will take it overarching entities at a point in our session, but then overarching entities basically are placeholders that help us map. Any data that we want to and connect it with the. What I mean by that is when you have a media buy or placement or campaign impression takes, etc. in your data stream. The data stream yesterday we have seen is the data stream type. Is adds data stream correct? And then when you upload something, a data stream from your Google Analytics, say suppose, which contains web analytics, site key, web analytics, site source, key visits, page views, bounce rates, so on, acquisitions, so on and so forth. So when those things come in, Datorama already picks it up as web analytics. Web analytics data stream, now campaign now. I have one ads data stream and one web analytics data stream. Now somewhere I need a commonality so that I can connect my data right. We will read it. So there comes the overarching entities, which basically allow us to connect other different types of data streams. Data, the different types of data type streams into a single bucket and helps us to join different types of data. So that is called an overarching entity. Calculated dimensions also is a type of overarching entity which lays above the data stream level, like calculations, formulas, or rules. Okay, it's workspace level. Remember this real-time queries that takes place throughout the workspace. Yes, definitely, calculated dimensions are something which accommodates this feature, whereby real-time queries can take place throughout, and also non-numerical fields present in your workspace that you can create on top of your existing data. So these are some of the workspace level things that you create above your existing data because you need some kind of an harmonization. Why do we need it? Because calculated dimensions are flexible. When we say flexible, it is at workspace level, right? So it is not bound by any kind of different type of filtration or any type of specific filters or specific settings or specific thing that we need to do. Nothing like that happens. Also, it is flexible and easy to maintain, of course, because it is one dimension that comes up and you can go ahead and edit it. And once you edit, you know what happens is there for the entire data stream, for the entire for entire data stream, for all of your data stream. This gets changed without hampering any sort of data. Applicable to all of the data in the workspace definitely, and supports a variety of functions and logical conditions. Yes, so basically calculated dimensions are used for this purpose only, whereby we have logical conditions and functions coming in. We need to we do tend to see what we see that what all we need. Okay, I have this kind of data and I need these things more. So what we do is we do a calculated dimension and we use our logical conditions and functions to extract or to harmonize or to get that dimension that is not natively present but needs a calculation in there. It helps us with consolidation of our data. So suppose you have definitely faced a situation whereby you see that your campaign category, or any of your field is not following the case or not following one taxonomy level naming. You will see that some or the other and it generally happens because we have our campaign uploading teams which shuffle which shuffles predominantly at each one in a world like that is always looking for. How fast can I do the work and complete it? So if 5 account managers have worked on 5 different sets of campaigns which are present for the brand, you will see that there are There are 5 different naming conventions. If not done correctly, 5 different naming conventions for the same thing that we have. And this is an example as well. Someone has written automobile, someone has written automotive, someone can write auto. And then everything falls under automotive. Same for communication. We have comms, communications, communication and all those things. But everything falls under communication. Similarly for tech. So we know that this kind of a scenario can happen. So we need a process of consolidating our data into automotive communication and technology. So for calculated dimension helps with this kind of an ask, whereby it helps us to culminate all the things together. Extraction. So we need to say, suppose we need another dimension from the first position of our media by name, which will help us to do some kind of an analysis. We see high gear, automotive analysis car world. Maybe these as a dimension will make much more sense with my measurement. And I want it as a single measurement which comes from the media by name. So calculated dimensions come into being and it helps us do that. Classification. Now, if you have your web analytics site source, which comes with something called Yandex, Yahoo, Twitter, Instagram, Google itself, and you want to classify your data into, say, search, social display, etc. Over here it's search and social only. So search and social calculated dimension helps us with doing these kind of work. So let's look a logical condition that we have used an if and a lower, and let's see what is the use case in which we are doing it. Simultaneously, we will see this in Datorama as well. So here we will see how to use an if logical operator in a calculated dimension along with the lower text function, and why do we need it as well. So we have this right now, we have the campaign category automobile and automotive which belong to the same campaign category. Right? So what we do is we go to calculated dimensions, we create a calculated dimension and then use the calculated dimension to get my set of things that I want. So campaign category needs to be uniform. So what we do is we go to the expression box and we go to if and the data was quick. Tip function is awesome because whenever you have selected one function from the list, what it does is in the below field it gives the definition for it. So when you see the data over here, you see someone in caps, someone in small. Some have capital D's and some don't have. So what do you need to do is you need to harmonize. So what? I wanted all my data to be converted to a lower. Lower is nothing but a lowercase and using it along with if so, what I do? I choose if and then lower. And what I want to classify is campaign category. Right, so I do an if and then campaign category contains auto more. So what it will do is it will from this list find all the fields that contain auto more. And what do you want it to do? You want it to throw automotive. So what will happen is it will go and check a first convert and then check the campaign category. If it contains auto more, it will convert it into automotive. Similarly, if you go and check, after that, if campaign category contains com, then communication, campaign category contains tech, then technology is. Always, if is always stacked with an else. So else is lower campaign category. Let's return campaign category. Nothing matches along the line. So how do we do that? We go to dimensions. We go to calculated dimensions. Choose this. So in my file, I have kept like 2 things. So how it looks like basically. I think I created a pivot for you. So how it looks like in the data stream is technology, technological, techno, automotive, 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 auto coming up. So what we do? We know that what I need to do is I need to classify my campaign category, right? And so what happens is you go to CAM. There's you select campaign category. There is a pane which lets you select the type which is text over here. There is something called a related measurement. I'll show you what is a related measurement. But just to keep in mind, related measurement is nothing but it adds context to your calculation. Okay, so if I have suppose I put the related measurement to be campaign key, what will happen? What will happen is it will compute keeping campaign key as a context for its calculation and per campaign key to do its calculation. This is a dimension thing, but if it is involving any sort of measurement, that needs to be sliced and diced. So a contextual measurement helps. It helps us with that functionality, and any contextual thing will be like, will be helpful. In case we want to do, we can add a contextual measurement which will be related, and the calculation will happen keeping this context in mind. What do you do? So the best part is you can go over here, and if you're doing an if, so you can choose this from here, and if you just click on, if you will see that below, it tells you what this function does for you, and you can drag it off and there, and you can write the function. So if, and then I want all my data to be normalized. So to normalize and use a lower function. And then campaign category contains auto, then automotive. If campaign contains com, then communication. If campaign category contains tech, then technology, else campaign category. Simple function, right? So how does it help us? This is before without uniformity, which gives me a total of 8366. And this is after it gets uniform, right? This is basically the calculated dimension that I have used over here in order to get the data. And I see that it works perfectly for me. So technology and automotive, which gives me this data which was previously scrambled around like anything, but the data is correct. So yeah, so this was the first example that we see, and once we are done with it, we before it was spread all across. Right? But When you categorize and when you do a uniform thing, this gets uniform and this gets categorized accordingly. Makes sense. That's cool. The second is extraction. So, I'm sure people are familiar with the extract function. So what we do is we create new dimensions based on existing dimension values. So what we do is we over here from our existing dimensional values, we use the extract text function and we extract some parts of the data which we think is relevant to us. Okay, so now you have your media by name which has the delimited values in it, which basically has some meaning, right? Higher, we, W, and everything has a meaning to it and everything is relevant to a single dimension which is relevant to a single column. Oh, so what you could do is you can go ahead and you have this delimited value. So there is one function called extract and your motive is to extract the first position of your media by name so that this first position of your media by name can be a single partition, can be a single dimension altogether when you extract it and you can use it for your various calculations and stuff. Okay, so pretty simple function is extract media by name. And you put the delimited place which is underscores because we have underscores over it. So what you do is underscores and comma 0. So why 0? Because in data indexing it begins from 0. So it is 0, 1, 2, 3, 4. Right? So the first position is referred to as index number 0, which basically what it does is it extracts your first position of media by name and helps you do it. So that's pretty self-explanatory. And once you have that out, you can use it as part of any filter and horizontal graphs or anything. So this is pretty clear, right? Yeah. So what I've done is I've gone to my calculated dimensions. I have added something called channel extract and chosen the relative measurement as impressions because what I want is this to dice the publisher or to dice the channel names or source names by impressions so that we have each row of impression can be classified, can be sliced using the extract function. If you don't use related measurement also, that is fine. But just to add context to our calculation, what we do is we add a related measurement. So what we have used is extract media by name and have an underscore, comma 0, which basically extract the first position. Likewise, if you see this example over here, we have the media by name and we have the channel extract. So this was the channel extract dimension that I've created. And when I drag it over here, what it does is it basically pulls up the first limited value along with the impressions over here. So now, using the publisher and using the channel extracted channels and impressions, what we can do is we can go ahead and create graphs and all which were previously not there because it was a part of the media by key. What we are doing is we are going to dimensions and we are creating calculated dimensions. And what you can do is you can do and add a new and you put a name. You choose the way how you want it to be. You write the expression. You find the functions over here, the number of functions, text functions, etc. You write the expression over here. You just go and save it. When you are, when you are building a table or when you want to see data with respect to the calculated dimension, what do you have to do is you have to just go over here and you're in your data. You can just pull it off. You don't need to map it separately or anything. Mapping is only restricted to data streams. This is not a data stream. This is a dimension that you are pulling to refer some calculation that you have done. And to see how the calculated column is giving you data keeping in like with a line to the native columns that come up. And the last example that I have for calculated dimension is classification. So classification is pretty simple again. And if you want to classify your data, what you can do is you can use the if statements. And you can do it. So web analytics site source, if you have which contains Yandex, Yahoo, Twitter, Instagram, etc. And if you like, you know the web analytics data that exist in several data streams. We just want to group these. Confidence of the column. We want to group these by not tampering the data stream, anything. We don't want to tamper anything. We want to group the site sources. So what we do is we are the search engine and we have the social stuffs over here as well. So what we want is to like a Yandex, Yahoo, Google, Bing to be part of the type search engine, and then Facebook, Instagram and Twitter to be part the social data stream. So what do you do? Again, pretty simple stuff. We use the if condition whereby we say that if web analytics site source contains Google, or web analytics site source contains Yahoo, or web analytics site source contains Bing, or web analytics site source contains Yandex, then it is part of search engine. And if it is Instagram, Facebook and Twitter, then it's social. And if it is nothing, then return other. Okay, so what it does is it basically helps us to classify those Facebook, Twitter, Instagram into social and then like the search part to the search engine. And we can see a group data of visits, time on site and then website transactions, etc. Correct? Calculated dimensions help us to group these data and these can be used in several graphs. We can now have source type is social and search and we can see the various types of and we can use that custom dimension that we have just now created along with the existing measurements in our data and we can have the relevant graphs. Okay, so what we have learned is calculated this is just a 3 example. That can be lots of examples for calculated dimension. But I thought let's take three types of work that we can do in calculated dimensions. Namely, what we have seen is consolidation, whereby normalizing my data and having a consolidated view extraction. And lastly, what we have is classifications that we can do with calculated dimensions. Always remember calculated dimensions are workspace level metrics and it works at workspace level. It doesn't need any mapping or anything. It can be used along with your native data and at a certain level of calculation that you say that you know. If I do this calculation, it will help me do some things, or if you see that your needed metric I've seen a lot of times in my project that fifth position in media by key is giving me something which is changing the entire scenario because it is the actual placement key or something. So media by key is different. And then when you have your at server placement IDs coming in, say suppose when we do media for center, which we are not doing as part of this training, we are just taking an overview. But then in media for center, if we have what we need to do is we need to compare that we can do that versus actually, which helps us keep track of the entire business in that position. We have seen that in media by key, we do have this at server placement IDs coming up. At server placement IDs from delivered and at server placement IDs from Prisma helps us basically map the placement in which our ads were displayed. So many times I've seen that specific to my company or other companies, what they do is they do tend to, in the delivered data as well, somewhere they want to coordinate the ad server placement IDs. So many times while mapping data, we have the fifth or sixth position has a data which when we look up with our Prisma data, we have seen that this is exactly the same IDs that we were looking for. And using a calculated dimension, we have fetched out all those information and we have mapped data at some level. That is not the end goal. But then, at some level we did get something and then some other solution worked for us. But then it can be used in such scenarios to derive a custom dimension for myself and get things rolling okay. So there is something called a light connect as well with us. Yes, we have total connect, we have light connect. Light connect is, as the name suggests, is a bit light and it's not that grave. It gives us quick and easy results. What you can do is it's a very pretty simple kind of a tool which helps us with. If I browse my data and if I choose something like this, right? So what Light Connect helps us with is right. Light Connect helps us create a data in which, I can go and directly edit this. It. What it does, it's what Total Connect does, is Total Connect brings my data and Total Connect tells me that, do you want to do some kind of filtration? You want to do some kind of a technical stuff, you can do. But Light Connect is something which helps me. If I want to edit the data stream as well, I can do it. So there is something called an add field. So if you go and add a field, it tells you what do you want to add. So you can add a dimension, you can add a measurement. And if you just add a dimension in here, what you need to do is you need to type any of the conditions or anything, like you can write if, say suppose in your new column, I don't have a campaign or I don't have a relative thing. But if you want this column to basically write something where you name this column and say you write, say your campaign has summer and winter and you want that to be, or you mention country. Yeah, so you can write that if my campaign, if CSV campaign contains country in there, then what is it? You can define a country or return, say suppose if CSV campaign contains summer, then return summer. CSV campaign contains winter, then return winter, or CSV campaign contains India, then return India. And what it does is it creates a new column for you, whereby you can just have your extracted feature and it acts as a new column, but based on operations and functions. If you want any specific examples for me to create for you, what I'll do is I can create one and showcase it to you by having the campaign data and all those things so that you know it is helpful for you to understand. But it's pretty simple stuff, dude. It's like just create a new column, and likewise, if you want to create a new measurement, you can just go ahead and choose a measurement and it gets added up here. And then when you create it, it acts as a data stream that you have created for yourself. Okay, I'll take. This is a very simple data set. I don't know how to reference anything from here, but then I'll choose a data set which has a campaign or something, and I'll show you how this logical function can help you build a column in here. Next is calculated measurement. This is something which you guys have already. Everyone has worked on calculated measurements, I believe as part of data delivery, and I am sure you guys know what calculate measurements are, but let us see how it works. So why calculated measurements? Calculated measurements combine data from numerous sources of data. It performs advanced calculations and statistical analysis, and definitely it has a flexibility and you can edit as you work. You find there is a calculation needed whereby you need to calculate 25% on your revenue or 25% of your media cost. That has acted. You can need to calculate a return on ad spend for yourself. Return on ad spend is a percentage metric, and return on ad spend says but return on ad spend works on your revenue and media cost. By the way, what is the difference between revenue and media cost? So what is the formula for return on ad spend? It is revenue divided by cost, and always it is a percentage. So always remember, ours is calculated in percentages. So whenever you are doing a business level analysis sometime or an account level analysis, ROAS is a metric that we do calculate in Python. Sometimes when we accumulate or aggregate stuffs, but in normal name formula way. Also we can calculate when you have your revenue and thing. In Python, we have hours as a part of modeling. We can model the hours in a calculated library from fetching it from a library. But then in normal, in Datorama and stuff, what we can do is we can go ahead and calculate it as revenue divided by media cost, and it will give me my hours. So if you are doing hours, and if you now want to see what will be 25%, or what will be 50% if I do the spend or something. So you can have the flexibility, you can edit as you are working, and you can go forward. What are the functionalities and what are the things? It is a real-time query again. Yeah, it is real-time, and it is again a workspace level query. So whatever changes in your native data, your calculated measurements will also change. Based on logical operators and functions, definitely can reference both measurements and dimensions, and it can return, and it always returns measurements. When I say can reference dimensions, that does mean is how the measurements are working with respect to dimensions. It is not, giving me dimensions. So what are the major ingredients that affect calculated measurements or dimensions? It is basically dimensions or measurements included in the expression. So ingredients in the expression dictate the level at which its query will take place. Sorry, above it will be calculated measurement and it shows up as calculated dimensions. So that is a typo. Please do ignore. measurements, so dimensions or measurements included in the expression. So basically, if the ingredients in the expression, when I say, whenever you are writing an expression for a calculated measurement, the ingredients in the expression and the associated levels of context or associated levels of related stuffs that we want to have for ourselves. Those things basically dictate the level at which the query will take place. I will tell you what I actually mean. So now say, suppose you are writing a calculated measurement and what you want is your total conversion average. Okay, now you have used average my total conversions and see what comes. Now there is something called aggregation function. So yeah, definitely it is self-explanatory that it refers to the measurement total conversions. Now, when I say that it is a work calculated measurements are workspace level measurements. It is applicable to the entire workspace. When we see that, and when you reference total conversion as a metric in your calculated measurement, it basically takes into consideration all the conversion tag data streams that are present in your workspace. All the total connect conversion tag data streams that you have in your workspace calculated measure. This calculated measurement, when you are creating it, takes into context all these data streams. And so when I say it is a workspace level, it basically works fine with all these data streams. It will work fine with all these three data, all the data streams which have conversion tag values or conversion tag data streams. What are there in my data? Okay, dimensions and measurements included in the view. So the fields included in our report, pivot table widget in which we display our calculated measurement will also play a role on how it will be calculated. Definitely right. When you have your native dimensions and measurements, you know what are your native dimensions and measurements. Our native dimensions and measurements are media by campaigns, site creatives, what else, anything like in a product. So these are some of the things which are native, which are coming from the raw data itself. But when you are doing a measurement calculation, when you are now taking all these columns, what you have created is a ROAS. So ROAS is return on ad spend calculation that you have done on your data, and you want to see it with respect to all these native dimensions and as well as measurements. So whatever measurements you have, you want to see how your calculated measurement works with respect to those measurements. So it depends how my native data is as well, right? So when I include my calculated measurement in a report may be having 5 to 10 native measurements, and then my calculated measurement comes in. So all these need to be relevant in order to calculate a measurement, to make sense, and to report the correct data as well. Similarly with report pivot tables. If you have calculated your pivot table, and if your pivot table has dimensions like site source, web analytics, site key and measurements like visits and page views, and if you pull the calculated measurement called hours, which is based on media cost and revenue, definitely it will throw up a 0. Why? Because it doesn't get any of the related measurements that are there that will allow you to. So your native measurements have to be aligned with your data stream as well, because if you put an ROS, your ROS will come up. In case you know, there is a common key and there is a common link between. So how your native measurements are along with your calculated measurement depends on how you set it and how you contextualize it. And of course, widget is nothing but your graphs in which you place your calculated measurements. So, for example, if when we add campaign name to the pivot table view, it will add, like when we add campaign name to pivot, it will add the campaign name to the context. The calculated measurement will calculate its query. So there has to be a context whenever we do choose any kind of calculated measurement, and we use it as part of any of the data streams or any of the pivot table. Granularity and aggregation. These are these are very, very important parts of calculated measurement. Because granularity, by adding a certain dimension in a view or adding the dimension in granularity in the calculated measurement. Granularity sets the context for calculation at which calculated measurements query will take place. Dimensional level of calculated measurements remains fixed as granularity. So, if you change any dimension level as well, if you have fixed the granularity, because why we need to choose the granularity? So that my calculation is true with all the granular, the most granular factor in my data. So what we do is we choose the granularity and we choose the aggregation as well, because aggregation is pretty much necessary when we do a calculated measurement. You do clicks divided by impressions and you put it as sum. So the aggregation to be sum. So it will return a sum only and it will never return a percentage. So your aggregation method has to be set as well as you choose your granularity. So what we mean by that, let's check by seeing. Some examples. So use case 1 is return on ad spend that I was talking earlier, and let's see how we do the return on ad spend. So return on ad spend is basically how each dollar translates into the gross revenue. So revenue by media cost. So each dollar, how much is that? How much am I yielding? Per dollar is basically return on ad spend, and it helps you identify overspending, unrealized potential and more. So revenue divided by media cost gives me. Now media cost is received by the platforms like Adform, U2Brain, DoubleClick Campaign Manager or by Excel. However, revenue is derived from Criteo, Bing ads, DoubleClick search, Twitter ads, etc. We need to have a combination between the two to write. So what happens is we need a calculated measurement, because now that the data streams of media costs are Adform, U2Brain, a DoubleClick Campaign Manager, and data streams for revenue are Criteo, Bing ads and DoubleClick search. So we don't have literally any connection between the both. So thanks to calculated measurements, which are which are workspace level calculations, which help us do the ROS computation. So calculated measurements, again you go to connect and mix. From there you go to measurements. From there you choose calculated measurement. You name it as ROS. We know that ROS is a percentage. We can choose any of the decimal places if I want to, 2 decimal places, 3 decimal places, etc. What we do is we go to the expression pane where we choose revenue divided by media cost. there is a field called advanced, which basically helps us at the granularity. Once you are there, you will see that you see total aggregation function. Below that you see granularity. So granularity is at a campaign level. Why? Because we want our ROAS to be calculated with context of campaign key. In other words, we want ours to be calculated per campaign key, and we want to see that how each campaign has contributed towards the ad spend and the revenue gain. Why we are adding a granularity? We are adding a granularity to our calculation. Firstly, to add context. Secondly, we want to see the return on ad spend per campaign basis. We are adding the granularity of campaign key so that our return on ad spend calculation works per campaign key, and we can see that value in our end result. We also need to add an aggregation function. So the next slide talks of that part so media cost by revenue is giving me the ROAS. Hey, revenue divided by media cost is giving us the return on ad spend. Fine, but what I want is per campaign basis. So you see the next. When we add the campaign context, the calculation calculates the values. Keeping in context the campaign keys. For each campaign keys, we see that there is a calculation that's happening and we get the context of it. So what it does is it takes the revenue of each campaign key and divides it by each campaign key. So precision and accuracy is something which happens which is always the end goal, and precision and accuracy stays when we add campaign key and we do the calculation of our results. Lastly, we have the aggregation method, and when we know that it is a percentage, we know that we have to select an average when we have a percentage. So our aggregation function is an average aggregation. So that's how it looks like. When we always verify your fields using the pivot table option, and we see that in the pivot table we have it. So now that we have ROAS calculated, we can use ROAS with all my functions like conversion tags, CT heat maps, top 5 ROAS, etc. So calculated measurement not only helps us with calculating a new measurement, calculating a measurement that is helpful for, seeing the performance of our native parts. Rather, also, calculated measurements are something which helps us with creating a new measurement which, along with my native things, can produce separate graphs, which makes the next calculated measurement that we will see is how to calculate number of countries. Number of countries. Calculation is nothing serious. But then suppose you have a data set which contains countries. Say there are 6 countries, but you have, suppose 10,000 campaigns. Or 10,000 campaigns are split across various countries. Or 10,000 campaigns are split across countries that you are not aware of. In the data set, you received the countries and you want to know what are the unique number of countries that are there for which the data shows up. So for that as well, you can use a calculated measurement using the formula of distinct count. So it is like how to quantify dimensional values using a calculated measurement, and then we will see what window functions are. So again, window functions are also, window functions are also one type of function which is used to provide context to the calculation that we are doing. So simply to assess and analyze the geographical exposure of the campaigns. If we see the campaigns column and we see that numerous columns going by here in the example, we see Italy and we see that numerous columns are there and we are not sure like what. Like what are they here? It is showing one country but says suppose you have around 15, 16, 18, 20, whatever countries you have. So at that point of time, what you want to do is you want to use a function called distinct count. So again, when we are in this example, so people do a sense check of data. So sense check of data helps us to, think about the visualizations even whenever we are just, and it is not premeditated thing that, okay, I have my data and in the email it is mentioned that the data is for 4 countries and I will go ahead and I will close my eyes and I will start creating the widget. But no, always. Whenever you receive any form of data, any kind of data, please do a sense check for yourself. That will help you know what are the components of data and you are now aware in your mind that you know what. When I need to progress keeping all these factors in mind so that I do not struggle with it later. So again, calculated measurements are workspace level. It is a quick setup that helps us and it is easy to update as we go along. So what we will do is we will go to measurements. We will create a measurement name. We will name it as number of countries. Now, when we see number of countries and the type will be numeric, of course, because it is a number. Before I go to the formula, always explore these 2 things. First is the measurement type declaration. Whenever you are doing a calculated measurement per se, and then look into the advanced option of granularity and aggregation, you will, so I have seen at times when we do a table calculation and when we create a table in our visualizations, I have realized that often what happens is you do, a click divided by impressions to find your CTR. But you will see that below, where the totals are shown, that comes as 0. So that is something that comes because, unless we set, because the aggregation is firstly you see in the below. Below in my screen, which I have taken a screenshot, it is showing auto write. So aggregation function by default is an auto, and whenever you do a calculated like say click divided by impression or clicks divided by cost, cost divided by clicks or something like that. So whenever you do that, what happens is Datorama does the calculation correctly, but then it fails to aggregate and show you in the table right. So when that kind of a scenario happens, we need to look into the advanced setting, which is over here, the advanced setting, and we need to check the granularity and aggregation methods being used. And once we are done with that, we will see that in the table calculation as well, the totals will show up, or else it sometimes fails to show up the totals. Again, as we saw yesterday, we need to go to functions. We need to type you type distinct and you get distinct count. So how distinct count syntax is distinct count. Syntax is basically, distinct count of cost. What you count is your dimension. Over here, we will count the number of countries. We will count this what is the distinct number of countries present in here. And then we will have the context dimensions. Context dimension is nothing but the but. providing the formula with a context to calculate to perform its calculations. So why a context is needed in these functions which are at workspace level and why not in the data stream levels are because data stream formulas are very particular and data stream, but formulas are very much meant for the data stream we are working on. But when we are creating any form of calculated dimension or measurement, it is at a workspace level. So the formula has a tendency of calculating everything that we want to write. So if you want the count of a dimension called country name or a country, whatever, so what will happen is it will start calculating the country for all the for all the data streams in my workspace. Wherever there is a column called country or a dimension called countries present, it will start calculating on that context. What is wrong over here? Nothing is wrong over there. But what is that our context will do? A context will always make it calculate based on the campaign name. So if a data stream doesn't have a campaign name, will it not calculate? It will definitely do. But when we do give a context to a formula, what happens is it becomes accurate. It becomes like, it calculates based on the keeping in mind that, okay, so I need to calculate this. Keeping in mind that I need to slice the dimension campaign. So when someone chooses campaign, what it should do is it should give the accurate value per campaign. Else, if you don't give the context, what will happen is wherever there is a country column present, what it will do is it will give you the count of those number of countries in your data stream. But definitely, I have seen a calculation with context and I have seen a calculation without context. In the same context, I have not seen any difference happening. But people do use window functions because window functions help them help them supply with the actual row that they want to see, and they want to have an accurate calculation by providing a context in there. So this context dimensions what we give. This is also called a window function, and window functions are often used with, the normal aggregation functions that we have. And with any other functions, like not only number aggregation functions, but all the whatever functions you can think of, and wherever context is necessary, those window functions can be used along with. So what? We were discussing the distinct count and count of country along with contextual dimensions. So that is what we were talking of. Window functions is basically which can be given as campaign key. So that we want each campaign key value is considered as one window for which it starts calculating the distinct count. Aggregation function. Yeah, that is what I was talking of earlier. Aggregation function is set to auto and it will be auto by default. So what we need to do is whenever we have a calculation, we need to go and check our aggregation function and we need to fix it accordingly. And whenever we have recognized what kind of aggregation we need to put it some count, accordingly average, and we need to see the calculation. So if we had a situation whereby we have campaign key country and day after we have created our measurement, what we need to do is we need to apply that And when we do that, let us look at the first box, campaign key 76919, which has the campaign key of 76999 and it has 3 countries. So what we expect is 3 countries coming. Let us look at the second thing, campaign key 72639. It has 3 countries. So what will happen is it is showing the 3 countries that are presented there and likewise the campaign key over there. So when we have distinct count, so distinct count will always be like, valid on the campaign key and country as we have provided with this. So distinct count country 3, the next one also 3 and the next one is 5. So we need to keep in mind that we need to use distinct count type of functions, which is one of the aggregation functions while we are working with them. So yeah, so that is it, I believe. So yeah, so another thing whereby we want the distinct count of all the countries that are present, and by I do not provide a window function. What we will do is it will provide me with, not provide me with, but it it will now calculate by keeping no context. So what we will do is it will calculate all the country columns that it sees dimension called country. It will calculate, and once you, but when you use it as a part of your data stream, it gives you the right answer that I have seen. Okay, so that is it. And once you have it set, now, you can use it as part of a geographical, you can use it as a part of the geographical charts and stuff. So yeah, so what we are now looking at is parent-child. Parent-child is a very important feature which basically helps us join the different data streams together based on a common dimension. Now, when we say that previously we saw that we don't have a particular method to join 2 data streams for our purpose. But in our data modeling, we have seen that. In our data modeling sessions, we have seen that we do merge data streams based on shared entities. Correct? So when we say that we merge data streams by means of shared entities and for our purpose, so think about this, that we have a say. Suppose we have common factors between 2 data streams, and what we do is we try to figure out that. What is that method that will help me with joining it? So we need to find a common factor in both our data streams, and the common factor allows us to, merge 2 data streams in the shared pool of data. So when you see the 2 data streams that are part over here, data stream 1, just don't think of what is a parent or what is a child, not currently. But just think that you have 2 streams of data which you want to merge together. And there are common factors which will allow you to merge them. The way we merge the data sets is called the way we do it. We create a parent data stream and a child data stream, whereby the child data stream inherits the structure of the parent and helps with merging the 2 data streams together. So that by means of the common factor present in our data stream, we can slice and dice the measurements and dimensions from both the data streams. So yeah, so that's what it says. Like there are the two blue boxes. Basically, it symbolizes the two identical stuffs in there, which helps us with merging stuffs. So to have an example, what we see that there is one data stream 1 and one data stream and a data stream 2. We have the dates, and what we have for both of them is media by key, media by name. For the first one, we have media by key, media by name, media by tactic and impressions. For the second data stream, we have media by key, media by color, tactic and clicks. So if we by any chance we see that the media by key is same, right? But if we look into the data stream from a point of view whereby we want to see the media by color in data stream 1, if I want to see the media by color and clicks, and if data stream 2 tells me that, dude, I want to see media by tactic, I want to see the data in terms of impressions, we will be at a fuss because because these two are separate data streams which don't have a connection among them, and we cannot merge them together. So likewise, if you plot the two data streams together, what you will see is a visual, something like which looks like this, right? So the visual that you see over here basically is telling that there is no media by color for the data stream 1, and then there is no impressions for data stream 2. Right. And then when this happens, we will definitely be at a fuss, and we don't want this to happen, and we want the data to be merged together. So let's check an example in Datorama by using these two data sets, and let's see how things look like. So these are the two data streams that we see. So if you see what we have over here, we have the media by key, media by color, media by tactic, tick and clicks in one and in the other. We have media by key, media by name, media by tactic and impressions. And in this one, we have media by color and clicks. Now, what we want to OK. So what was our file name? Parent, child example, right? Parent, child to example data set 2. Duplicate. Okay. So you see, it's pretty simple mapping that we have done. It's a total connection whereby I have uploaded my Excel files where we see the media by key, media by name, tactic and impressions in one data set. And in the other data set, we have day media by key, media by tactic, media by color and clicks. So when we have mapped media by color, I'm sure it is. So when you have a dimension which is a part of your media by, we have discussed that. How do you map the attributes of a certain key? What is the model field that we map over here when we want to map the attributes of a certain entity? The first day we had discussed, not the first day, the day we have data modeling and mapping. We saw that time we had discussed that. How do you map attributes which come in into your raw data? We have model fields, right? We call it as media by custom attributes, right? We have custom attributes that we saw. So whenever there is an attribute that you want to map specific to a particular entity, you can go and map it. Correct? So media by color is nothing like a default mapping that Datorama recognizes this attribute to be. But will I not map it? Definitely I will. So what I have done is I have mapped it to a media by custom attribute, which was its original name. And then went ahead. And so this is one way. When I'm here, let me just show you model field properties and move forward so that one thing is covered also. So suppose I'm just unmapping it. So suppose there is media by color. And you have done this like you know. What you do is you select media by color over here from the left. And then you select like you know, write media by custom attributes. And you see that so many custom attributes come up. So what you do is you select one media by custom attribute and you can apply. Now, if you apply, what happens is when you save the data stream, now what will happen is this field will be ingested into the Datorama data pool by the name of media by custom attribute for. Now, when you go ahead and when you pull it as part of your, say, report or visuals or pivot or whatever, pivot and report, okay, you want to see the data only. But when you have it as a part of your visualization, it seems to be like it looks very odd, it looks very long. So now can I not change any names over there? We can. But why will we do that when we have an option to change that? The inception itself. So what we have to do is, once we have mapped this, we can go to this model field properties. And in model field properties, you see there is something called original name, which is media by custom attribute for, and display name, media by custom attribute for. What you can do is you can go ahead and change it to. You can change it to media by color. Now what happens? This metric goes with the name of this, but in the data model it is correct and it won't give you any aggregation issues. So there is something like, here also you can go ahead and you can choose if it's a text, if it's a date, link, image, whatever. Or if you want to revert to original, you can do that as well. So that's basically the properties that you can venture out. Now we have these two things. Now someone tells you that, dude, you can. You have to go ahead and merge these two. And I want to see media by I want to see clicks and impressions both along with media by color as part of the same data set. Now, if you go and when someone tells you this, once you go and look into this, without doing any sort of parent, child or any sort of thing, how it looks like is okay. So So you see that how it comes is, you know the media by, and then you see media by color. Media by color is not present in one of the data that I don't remember 1 or 2, but then 1 in 1. It were not present. But it gives a wrong value over here because we were toggling around. So it gives a wrong value in ideal situation. What happens is dimensions, and dimensions are comes as default values. We have not said. I'll show you how to set default values for whenever we want anything to not pop up or pop up in a random numbers, we need to declare that. Wherever you see some kind of a value which is not correct, anything other than the condition, you need to return a default value. I'll show that when we do harmonization center. Next harmonization center, maybe we need to declare this thing. But if we don't do, some random number comes up which is not correct. So just ignore for this, and I'll show you like how we solve this as well. But the purpose of over here is not that. The purpose is we are getting like 4 for 1, 2, 3 media by key. Also, we get a default media by because we don't have the measurements and it's not correct. However, and for 4 or 5, 6 as well, we see a default media by and things are not look correct. And for wherever there is clicks, there is no impressions present and it is not joined properly. Now we understood that for to correct this thing we need to do a parent-child relationship, keeping in mind that we have media by key as one of the solid players in our code, and it will solve things up. Before doing a parent-child, let me tell you this. And please keep like if you are making notes. I'm not sure if you make notes or if you do something, but do remember a term called hierarchy. Now, hierarchy is a term which is as data model or data modeling, and it's various ways we have discussed, and we have seen that it's very important. Likewise, hierarchy is something which is very important as a concept to remember. Now a data stream with full hierarchy. Whenever we say that a data stream contains full hierarchy, that does mean that a data stream contains media by campaign and site. Whenever there are components of media by campaign and site for any of the data streams, that is considered to be a data stream with full hierarchy. Okay, then if it is, then what happens is always we tend to make the data stream with full hierarchy, the parent, and a data stream which doesn't have the full hierarchy. We consider it to be the child. Why? I'll tell you why. So a data stream which has full hierarchy. What happens is if it dominates the data stream with less hierarchy or with no hierarchy at all. So what happens is this, if this is told to be the parent, so a child always inherits the properties of the parent. Correct. Now one data stream which contains media by key, media by name campaign, key campaign name, site a key, site name. If is dominated by a data stream which only contains media by key and media by name, what happens is that It doesn't have campaign values and site values. So all these campaign values and site values goes for a toss and they show default values. Whenever we talk of default values, default value is nothing but blanks. Okay, so whenever it will show you, default values, which would have been the case like, oh, you see default media by likewise. So if it shows a default value, so what will happen is if a child dominates a parent, or forget it, if a data stream with less or almost no hierarchy and dominates a data stream with the full hierarchy, what happens is we won't get any result out of it. And we will have wrong values, and most importantly, we understand right a media by to media by map. But then what? Where did the campaign and where will the site go? It will be default values. Having said that, now do we understand that which one will be a parent and which one will be a child? So over here in these two data streams, what do you think will be the parent and what do you think will be the child? Forget how we do or what we do, but just if we try to assess these two data streams, what do you think will be the parent and what do you think will be the child and why? The data with impressions will become a parent like it has the media buy and the impressions and all those. It's common in both, but the media by color will become the child because it will just give the coloration for those two. No color is an attribute. Likewise, media by tactic is an attribute, right? So, and we are talking of hierarchy, so any other guesses? I think media by name is there in the other files. So that will be. That's fine. It's only the keys. So whenever you do lookup in Excel, you do a VLOOKUP, right? So in VLOOKUP, what do? You map your IDs to IDs, right? And then you pull the other things, names or something. Because what do you know is, in my lookup, my IDs will be correct and IDs are always to be referenced and not the names. Correct. So likewise in join as well. How do you do a join? You do it by referring to the common ID and then you do. And I'm sure if you guys understand join, then you must have understood that this parent child is nothing but a full outer join. That we are doing correct. So in full outer join, what we do, we bring in everything. So over here as well, what we are doing is, this is nothing. But if we just talk data structure, then it's nothing. But it is a full outer join that we are doing. So it's always IDs correct. So then which will be parent and which will be child? Like the sheet with the media by name, it has all the information like the date and the media by key, media by name, media by tactic and expression, except for click. So that will be parent. I think both are child. Both are child. Okay, no one has to be a parent. So in this case, we don't have a hierarchy at all because we don't have anything apart from media by key present in our data. So in that case, whichever data set you choose can become the parent and whichever data set you choose can become the child. Okay, because we don't have any hierarchy in our data. Okay, so now let's go back. And now, how do we do that? We go to our data streams. This is our data stream 1 and where is the data stream 2? Do you see the parent-child example? This one and this one. This one. Okay, these are the two data sets that we have in place. So let's do something. Let's make this one parent. Let's make data set to the parent of data set 1. How do we do that? We have to do an edit. We go to parent child. In edit, you will have yesterday we saw how yesterday, I think day before, we saw load rules. Likewise, below the load rules, you have parent child. So what you do is you go over here and you take this as your parent. Right. And what do you do is you save it. Okay, now you see the parent stream over here. You see the parent stream over here has changed to the data set 2 and data set 1. Now go to visualize. Okay, now you see we have media by key 1, 2, 3, 4, 5, 6. We have name, we have media by tactic, we have media by color, and we have the respective impressions and clicks for the media wise. And we have slice clicks and color with respect to data, set 1, and media by tactic and impressions with respect to media. Not media by tactic, I guess clicks and media was there, and impressions and media by color. Those things were we wanted to see as a part of it. Okay, so as we do not have a hierarchy, you can go ahead and you can do the other way as well. And it was the identical way. So that is how we dot the parent-child. Now we will see two types of yeah. So we took an example to see what is parent-child and how it happens. Now we will see this scenario which he just asked, and another scenario whereby we will do two types of parent-child. One will be a parent-child within entities and one will be a parent-child across entities. And we will see two types of data sets whereby we will now look into hierarchy and we will see how things are done. The one which we did now, it is also within entities. Now let's see another example if it is not clear by us. So another data stream, another example to see the data within entities. Okay, so I have another set of data set that. Let's see how it works. Will this come over here? This is a better view. Okay, so you see again we are again. we are in a situation whereby we have the date. We have our media buys. We see that the first data set has 3 media buys by keys. The PC2 has 2 media buys by keys, and then we have a media by name. We have media by attribute and impressions. Over here we have media by key. Alongside we have media by category and clicks. Right. So now the data set. One wants to see the media by category with respect to media by category and clicks with respect to the media by key and data set. One wants to see media by impressions, media by name and media by attribute in terms of media by keys. Now we are at another stage where we know that, okay, this, if we want to have as part of a single data set, what we need to do is a parent-child, right? So that we can culminate the two streams together. And then let's visualize once how it looks currently. So it looks like this, right? You have your media by keys, and then your categories are not present and impressions and clicks. Wherever impressions are, there are no clicks. Wherever clicks are, there are no impressions. Media by category is not present. And then media by 1, 2, 3, and then one has the media by 1, 2, and one has 3. This is not coming in the right format as well. If you tell me that why is data coming in where it should not have. Because these dimensions are referring to one another and they are putting the media by names. But do not be concerned. These can be like this will be default values whenever we set it in harmonization center. But matter of fact is not. That matter of fact is media by category is one of the new things that needs to be classified, and impressions and clicks need to come up. Right, and because they are not sliced. Now let's do the way you see it. Let me go back to data streams list and you see PC1 will be my parent. So I'll abide by that. So whatever you choose as parent, the other one has to be the child. Right? So never do. So this one you want to be the parent, right? PC11. So always you need to edit the child data stream. Don't edit the parent data stream, or else you'll keep on searching and you won't get it. So this is your child data stream. Okay, you go over here and you do an edit. Go to parent child and search PC. Okay. So you see PC11 is now the parent of PC22, and see what difference does it make. Do remember that in Datorama, whenever you have made a change at whatever level, if you want to see it effective, do refresh. If you don't refresh, you won't see any changes happening because, yeah, Datorama is a bit confused in those terms. Okay, so now you see you were correct. So we needed to have that as the parent, and now when we have it, we see that we have all the things classified properly, right? Now this is called parent-child within entities. Okay, now let's see an example which will be parent-child across entities. Now let's talk of hierarchy. We have mentioned hierarchy in our OK. Now we have two data sets. In one we have date, we have media by key, we have media by name, campaign name, site name, impressions, and in the other data set we have media by key, media by name, and clicks. So we have discussed, right, that we need to always consider what we need to always consider data stream with full hierarchy to be the parent. So here we see a data set which has the full hierarchy and we determine it by media, by key name, campaign name, site name. Everything is presented there and we have clicks over it. Now it's the same scenario. I'm not asking anyone. I know you guys will give me the correct answer. So I'm considering the fact that we will take the data stream, one that is PC1 to be the parent and PC2 to be the child. But let's see what happens if we take the other data set now comes. I don't know. I guess Salman had asked this question right, that if we take the child which we were supposed to be the parent. So let's be no right, we need to do it this way, but let's do the other way. Let's take PC2 to be the parent and PC1 to be the child. Now my data looks like this. It is not aligned. It is nowhere close to aligned. We have our defaults and all these things happening. So let's go over here. Which one we want it to be the parent PC2? So we will edit PC1 and we will edit and we will go to parent child and we will take. PC2 as my parent, that's it. Processed. Okay, processed. So let's go back. Let me refresh. So you see what has happened, and campaign name and site name was not present in the other data set, right? In this guy, PC2, we didn't have the campaign name and campaign name. I go somewhere else. Campaign name. Site name, we didn't have, so campaign name and site name has become default. However, because media by key was the same, it has given me the correct clicks and impressions have got merged together. But these two went for a toss because these two were not present and your data stream didn't have this, so it will return a default value. Okay, this is what happens when you choose a wrong parent. Wrong parent sounds funny. And another one thing, if you want to remove the parent and child, can we make these changes? Can we update it? Removing the. I didn't get you. You mean if I can go back to the original stream? Yes, yes, yes. That's how I'm working, right? So that's what I did while I unshared. Now this is your parent, right? You have identified this is not working. So you do an edit. You go below. You have this, you select unknown. And you save it off. Okay, so now once this gets removed, we will be back to the original shape. Did it get removed? These are all pending jobs. Let this happen. It's successful now. If you see once, you will be back to the original shape of data. And then we will rectify. Okay, we are back to the original form. Now, what we will do is, we will not do the similar mistake anymore. And we will make PC1 as the parent of PC2. So where is PC2? There is C2. Go to parent child. PC1 to be the parent. Okay, it's done. So let's refresh. Okay, now things look good to us, right? So what we did is we did a parent-child across entities because across entities, parent-child is something which will be like, I think life won't be similar like the other ones, which we did within entities because that is the rarest of rare scene that you will face. But always what you will face is parent-child at like, within it across entities because most of the data sets will contain more than one or two dimensions. First, so while doing parent-child, what you need to determine is first thing is what is the shape of the data, how are two data sets shaped, and what are the components of those data sets. Second, we need to keep in mind this word hierarchy because this will be coming at all stages, at every stage that we overcome and as we As we go ahead, we will see this option coming up again and again and again, and we will be talking hierarchy because now we will talk to more concepts. While we do parent, child, our override dimension hierarchy, and we will talk of update entity attributes. So these are the two concepts that we will introduce now once we have learned the concepts of parent-child. These are the two, again very important options which come to our rescue at times, but with parent-child. First is determine what are the components of two data. Second is, do I have a common key between two data sets? Third is, what is the hierarchy? A full hierarchy is always when we have a media by key, campaign key and site key and that is considered to be the data set with full hierarchy, and always the data set with full hierarchy is kept as parent and the data set with least hierarchy is kept as child. Because we want to slice the entities even which are present in our data. Correct. So then what you do is then you go ahead and establish a parent-child connection. Remember, whichever data set you want to be the parent, always edit the child. So the child data set is always edited and the parent is put, and then go ahead, and I have done it in visualize in a visualization table widget, but always do a pivot table and see that your data is joined together or not. Always keep on checking. Okay, cool. So let's go back to our cool. Let's go back to the PPT and we have seen multiple examples. So things will be easy for you. So yeah. So it shows a magic wand which basically transformed all your data and all that is different. But let's understand the concepts once more in visual so that it stays back with us. Data stream 1 and data stream 2 has 1000 impressions and oh yeah, this is very important. So parent-child relationship doesn't determine how your measurement is being sliced. What I mean by that is data stream 1 and data stream 2, like parent, child or any other sort of harmonization and dimension level, doesn't affect my measurement. If data stream 1 and data stream 2 had 2000 and 1500 impressions respectively, we will have 2500 impressions. It won't determine that. Oh, this was the parent, child is wrong. So let me show the measurements wrong as well. No, it doesn't happen like that. You have seen right the campaign for which we had default campaign and default site. Those were wrong. Those were not correctly coming, but our impressions did come correctly right when we have merged together. So keep in mind that parent-child or any other dimension level changes or harmonizations won't affect my measurements. So data stream 1 contains clicks and data and the dimension media by color. Data stream 2 contains media by name and impressions. So you do a parent-child relationship between them and you want to have all these, like, the clicks with respect to media by name. So what you do is you put the common entities in your pool and you get it. So keeping in mind always and engraving it rather is the entity key, entity name and entity attributes. Because the concept revolves around that. The concept always revolves around these factors of entity, key entity name and its attributes. How are they configured? And in data as well, by doing these harmonizations. What we try to do is, for a particular entity key, we want to get the correct entity attributes configured along with. So when you first introduce a data stream and its attributes to Datorama, what happens is a hierarchy gets created. When I talk of this hierarchy again and again and again and again, what we have seen is a data stream hierarchy, which basically is like you have an Excel which contains media buy and then it contains so do something. Let's try when you get some time to upload an Excel which has media by media and campaign inside and then whatever impression takes and everything. Now, there is one process whereby what we can do is we can upload updated files. Let me show that so that it becomes easy when we talk about these things. So let's say we have suppose let me work with PC2. So PC2 parent child is there right now. Tomorrow or PC1 is open. So let me do with PC1. So PC1 parent child, right? PC1 parent child is there. Now I am showing you with data sets in silos, but your data sets won't be like this and you won't be doing a manual job, right? You are taking up Datorama because you want automation to happen. So your data will be automated always. But let's say, suppose you get some data which comes in form of Total Connect. You download it from your Google Ads or you give your account manager. Gives you per month. So what do is you upload and update the Excel. Say, suppose this is your Excel and you have updated 3 or 4 columns beneath this 4 6 and then 5 6, then 6 6, then 7 6, then 8 and you have added in here. And then what do is you want to upload it in the same data stream. So how do you do that? You don't create a separate data stream again and again. But if you go to process and say select a file, drag or drop. So if you just go over here in your folder, I am in my folder. By the way, you don't see my folder, but when I drag it up, you will see. Or let me do in this way so that is clear to you guys. So say, suppose I choose this. So what happens is when I do a process and I do it in the same data stream, my data stream gets updated. So what happens is it gets updated whenever I tend to choose anything from another data, but if you try to in the same. So, but how is it happening? How is it? How is it allowing me to update the Excel file and upload it in the same data stream? Because we are abiding to the hierarchy of it. Now, if you remove something or if you have added some columns over here and then you go ahead and try to process, no, it won't allow you to do that. So what it will tell you is like you need to go back and you need to map it again and you have to have the new columns to be new columns to be mapped back. And you define the hierarchy in a new manner, which is very similar to creating a data stream. But then once you introduce this thing to Datorama, what happens is a hierarchy gets created and this hierarchy can be updated. But seldom do we change the hierarchy to change. Say today you have your Google Ads data which consists of a date, campaign, ad, group, keywords. And then backed by impressions and clicks. So when you are in the month of, we are in the month of June. When you are in the month of July, what happens is you get your July data. You get your July data, but it is in the same manner, right? So when you have June data, you go ahead and place your July data below. Whatever you do you updated your Excel, you update your tables, you update your Redshift table, then you bring in. But what you do is you abide by the hierarchy, right? So we need to keep this in mind that whenever we are introducing anything, we are updating our hierarchy. And oh shit, you've seen this. I was intending to show you this. I am sorry. So whenever you introduce the, so that's what I was saying, you have your Google Ads data, which has a hierarchy, and when you place the data below over here, it basically gives you the next set of, like, July data. You place below by means of any updation that you make, but you always abide by the hierarchy. That is what is needed. Okay, and we will see that. What we will now see is how the hierarchies are important to us and what happens if we toggle some of the options in the so that we need to update or change some things in our data. So as the data model tutorial made us understand that a person cannot have more than one height at a single point of time. It is the same with media by keys. Even so, if we talk of a media by key, it cannot have one media size in a given time, and an entity can have only one value of attribute at any given time. So when you add an entity key, you are also adding a complete set of attributes for the entity. So you add the whenever you. So basically, what it is trying to tell you is whenever you are introducing any data header or data column, your data abides by it. Your entire hierarchy is abiding by it. So whenever you have introduced your data now, say, suppose today you have introduced your Google Ads data which had media by key, media by name, color tactic, etc. But it didn't have a targeting type. So your raw data didn't have a targeting type in Datorama and you have introduced it. So now say, suppose you want to update your data with direct. Will it be possible to do without doing anything, without doing any kind of harmonization changes? How will I make change to my raw data, or how will I change because my hierarchy is done? My hierarchy is set. I have introduced my raw data. I have done, logged and done. Now, I am not talking of creating. Like, you will say that, oh, I can go back and I can update my Excel and I can come once again. No, I am not talking on that. What I am talking of is that is making change to your raw data. We are not talking of raw data level changes. What we are talking of is in the tool. When you are there, and don't think it as an Excel, think it as, say, servers and clusters of data that you have introduced and you want to update it. When you have your media by targeting type as blank, it will always throw a default. It won't be giving you to update any data anymore unless you do something. So, yeah, the hierarchy is logged. You cannot update it in there. So then comes the option called update entity attributes when they change option. So what it does is, if you wish to update the existing entities attribute, you have to check the update entities attributes when they change previously, and now it is there by default. But what I mean by this is, but now what happens is update apt attributes is something which is, like by default, it is there. Now, if you want attributes and hierarchy inherit attributes, you can go from there to other. But by default, what happens is update attributes as the change is checked, so that you face any situation like it was not there previously by mistake, but it is now there and I want to make some changes. So what happens is you have this update entity attributes when they change, when the change option, which lets you update your entity attributes if it was not there in the previous iteration previously. Previously, if it was not there and now it is there for you to update it, and you can very well go ahead and you can update the attributes in the places where you want the data to change. If it is scheduled, then nothing like it, because if it's a scheduled data whereby it went for a miss and then it has come once again updated. So what you need to do is you need to go ahead and do this update. Attributes is checked, but yeah, if it is a past data, if it's a historical data that needs to change. What you need to do is you can process last 90 days data, and if you want to go further as well, you can write to the Salesforce support team and they will go ahead and reprocess. We often do that, they reprocess the entire data stream from the start so that we have it. We have this done and we can reprocess the entire data if there are changes. But if in the first instance the media by targeting type was not there, but in the next iteration it has come up, it always gets updated. But do remember one thing, what that is a media by attribute or any sort of any attribute to an entity is mapped at a one-to-one relationship, because at a certain point of time, one media by key can have one media name and it can be attributed to one attribute value at a single point of time. So 1, 2, 3 and default by cannot have direct and indirect may be targeting time at targeting type at a single point of time. At a single point of time, it is never possible for an entity to have two attribute values. It will only have one attribute value. If that gets updated, what happens is the data in media by targeting type field gets changed, but never does it get added. Because that's not how data runner works, or that's not how the entity relationships in a data model works. So what happens is you check it. What happens is the hierarchy which was logged, it opens. And it accommodates the direct type. But if with direct it comes with indirect, not so direct, perfectly direct or anything at a point of time, it is never possible and it will never get added because it is at a one-to-one relationship. This will help you to update the attributes for the existing entities and help update the new values. So one more thing that happens is it will attribute. Values are never constant when you do this, and I always feel that you have to keep it checked because once you check it, what happens is it will always be updated with newer values, and this is very important. Why? Because you must have working in this industry. You must have seen that our classification sheets or what we consider a source of truth. Those sheets keep on changing at fiscal year level, at financial year level, at monthly level, at quarterly level. You see that things keep changing, right? So I feel update entity attributes is a blessing because at real time, whenever your fiscal year changes or whenever there is a new introduction of a sheet or new introduction of a new classification that you want to do for yourself, you always have update entity attributes. Whenever you have changed it, update entity attributes goes ahead and it basically updates the entire hierarchy of data, not only giving you the hierarchical data, but also helping you to always update it with the newer values as they come up. So now the example that I was talking of, that is basically shown in the slide that I said you write at any given point of time. There can be only one value per attribute for a media by key. So tomorrow, if direct changes to geo-targeting, it gets replaced with geo-targeting and not added up, right? So new targeting type will only be the targeting. One targeting type associated with the media by key and old values get replaced. Okay, so clear. Now comes the same concept in terms of media, in terms of the data model. So when we have the data model, think it as an Excel sheet. Okay, so media by key is nothing but your placement ID. Media by is your placement campaign key, creative key, site key, and creative key. All these things come as a part of an Excel, but think from the purview of Datorama. This guy gets a new Excel. What it does is it creates a new hierarchy and locks it. Why? Because if it does not lock its hierarchy, what will happen is tomorrow, if a data comes in which has a different structure altogether, and if it allows that to override or if it to get appended along with, what will happen is your data will become inaccurate, it will become a mess, and it will become cluttered, and everyone will say that it is an inaccurate tool. What happens with what it is called in Tableau? Tableau, what is often data blending, right? So I always advise that do not use data blending in Tableau. If anyone is working in Tableau, will know data blending. I am sure it is not a harmonization tool. Data blending works fails miserably. Like I don't know with which batch I have a Tableau session as well. If it is with this batch or any other batch, I am not sure. But then there is a Tableau session as well planned. So when we will do Tableau, if any one of you are there, we will discuss then as well. But then in Tableau we have data blending. Data blending is done on basis of this shared entity and shared stuff itself. But it fails miserably because it doesn't have some kind of a data modeling. Tableau doesn't have a data modeling like it definitely has, or else it cannot show the rows and columns. But then it is not that high level, or it is that not that well thought of when it comes to data blending and data model together hand in hand. So data blending fails whenever we have a server level data or we have a huge data coming in, data blending fails miserably. But in Salesforce, they have what? First thing is on data modeling, so that once you ingest a data, for that a hierarchy is created and logged. So once it is logged, now you go forward with whatever you want to do. Use harmonization tools to overwrite whatever is there. But by default, you cannot do anything, or by default, you cannot toggle with any kind of accuracy. So it is the same thing. When you have a data, you have put it in there. Just try to think it in this way. Let me also share when I say you ingest it. Just try to think of this data set. This you have ingested and you have told that you know what was for the, I don't know, it is what, 3rd of June or I don't know, 6th of March. Whatever the data format is, forget it. For 3rd of June 2022. This is the hierarchy. This is the data that you need to keep in your repository and you need to work towards it. What this guy does is this guy updates, uploads it, and this guy locks it. Then you throw a bomb at Datorama. You say that you know what, for June 6, the campaign name that I had given you was wrong. So previously you have given him the campaign name as campaign ABC, and now you hint that the campaign name is not ABC, but the campaign name is XYZ. What will happen? So this guy will be confused. Nowadays, if it is an attribute, now think of it in this way. If it was an attribute of an entity, you can go ahead and you can check the update entity attributes. Okay, so this was easy for him. But now you are telling him that my entity is only wrong or my entity has updated by some mistake. What happened is my API has failed to recognize the reports or recognize what was going in at the tool level or at the placement level at the publisher level. What was happening? My tool has failed to track it. My API has failed miserably. But now when I have updated the wrong data, now this has come up with the right data. Now what you do is, so this guy asks you if it is an attribute that I need to update because I have it checked by default. But no, you tell him that, no, you need to go ahead and change the entire hierarchy of data, starting from changing the entities. Okay, now he has logged this and you tell him that campaign name was not A, but it was AA. So how will you know what will happen in that scenario? So, however, sometimes you will need to change the hierarchy and correct an error in your report, which was uploaded. Not a report, but it is a API level failure maybe. So A, B, C needs to be replaced by XYZ. So then comes one option called override dimension hierarchies, which you need to check. So once you check override dimension hierarchies along with update entities attributes, what happens is now it unlocks the data model from entity level. When you want to change the entity, you go and tell override dimension hierarchies. You check it. So what happens is your entity level gets unlocked and your data model gets updated. Oak, so entity. Then I say it comes over or you are not seeing my screen again. No, later on. Oak, so there is something called. Move on. There is something called override media by hierarchy. So they have changed the name to media by hierarchy. But it is basically override dimensions hierarchy as they change. Now what happens? Now my campaign levels gets updated from A, B, C to XYZ. Ok, but now we need to keep in mind one very important thing. That is, when you check override dimension hierarchies, you need to keep this always in your mind, engrave it, write it off, put a sticky note, whatever you wish to do. Write in your wall that whenever I check override dimension hierarchies and I have updated, don't fail to uncheck it as well. Ok, so that's why you must have seen that override update entity attributes is always checked by default, but override dimension hierarchies is not checked by default. We need to check it when we need it. Till date, I have used it only once. Okay, but you may need to update things from your side if at all it happens. It doesn't happen anytime, but it can happen in a million years. Write that something like this has happened, whereby you need to change the campaign name for a historical data. So why I am telling is that you need to change. Once you have done it and refreshed your data, always uncheck the Override Dimension Hierarchies button. Because just think, if Salman at one day, under the sun, he has brought a blank report with himself and he uploads it to the same data model and he has given override dimension hierarchies, what happens? The entire hierarchy gets changed to a default. So campaign key becomes default, creative key becomes default, site key becomes default, media buy key becomes default, because all the dimensional hierarchies entities are now changed to default when you override it with a blank report, right? So override dimension hierarchies. As soon as you have checked it, you should uncheck it or else. Or else doomsday waits for us. So let's say you have left the ODH option checked and one day Salman has got a blank report and he uploads it. So what happens now? Everything becomes default campaign, default media by default site and default creative and you have nothing left and it cannot be undone. And what happens is, by means of this, your entire data structure goes for a toss. Why? Because your one data model has completely changed into default. That does mean that your data was set up in a parent-child mode. Say suppose, if it is a parent-child mode, then entire parent and child gets screwed. If it is set at a classification level or it at any level, you can think of it gets updated and it gets screwed big time. Okay, so once you have update entity attributes is something which has to be always checked. You have no option now. Datorama has updated himself and it has kept it updated all the time. But update entity attributes basically help you to update the entity's attributes at real time, and it's not a constant value. But whenever your attributes change, it basically changes. Keeping aligned the other factors and it gets changed, and then similarly with override dimension hierarchies. What happens is at entity level, whenever things get done or the entities get updated, the entities at entity level, whenever we want to make changes, we can do it by using the override dimension hierarchies. It basically is changing the entire hierarchy of data for you. But as soon as you have recognized and you have done it, do uncheck it, or else whenever there is a new hierarchy or whenever there is a new set of data that comes in your dimension, hierarchies get shuffled and that results in screwing up the entire connection that you have harmonized and automated. The entire automation goes for a toss and you're left with nothing, or you're left with some data which is a mess and cluttered altogether. Okay, so your default hierarchy is the only hierarchy and everything is gone. So parent-child use cases. What we do is, why do we use parent-child for integrating measurements and integrating dimensions? So, if we have a data stream A and data stream B, we have seen all the aspects of parent-child. So I'm just taking it quickly from here because I've shown you all the types of parent-child that can be done. So data stream A is the hierarchy. So here, what they are telling is a hierarchy, but always keeping in mind a full hierarchy and no hierarchy, or full hierarchy and a data set with less hierarchy. Maybe so media-wise, site-wise, campaign-wise. Okay, keep this as a note as well, that whenever if someone asks you what is a data set with full hierarchy, it is a data which contains media by site and campaign. Okay, so you have data stream A as hierarchy, and then data stream B has come up with an added measurement of conversion tag, like total conversions, and it also has a conversion tag key along with. So you want to join your display data with conversions data. Now the first data that you see, it's basically a display data, and the second data that you see is a conversions data, and you want to join it. We will work on something called overarching entities the next week. That's what 2 or 3 topics are left. One is overarching entities. Overarching entities are very fabulous thing that they have given us, which we call as custom classifications. Okay, as we have custom attributes, which are basically help to classify the attributes, we have something called custom classifications, which we will do after data classification, which are called overarching entities, which basically help us connect both the data streams of different types. Over here as well, we want to join our display data with conversion data with a, but what over here it has as VR, that is like a, what do we call it in? That is like a foreign key that we have a primary key and a foreign key, right? So custom classification acts as a foreign key in helping us join the data. But over here what we are doing is we are doing a full outer join based on a common thing. So my conversion tags data and my display data needs to be added together by means of a media by key. And so the goal is to slice total convergence data not only by data stream B, but also by data streaming as data stream as the full hierarchy. So we see that the parent-child doesn't affect measurements, but it allows us to join several data sets of identical entities. And let's see how it happens. So we need to achieve this by using data stream A as parent data and data stream B as we have the common keys of entity key. To achieve this, data stream B needs to have date media by key, which basically is an entity key based on which the data sets will be merged. And thirdly, any measurement that we want to add it, like, so over here we want to add convergence, right? So our main goal is what? Our main goal is whatever dimensions the parent and child has, all these things need to be sliceable with the measurements that we have, and like, a campaign key should slice the total conversion. Media by key should basically the data set of values. Media by key, site key and campaign key can slice the total conversions. Right, so that's what is shown in the box, is that my data streamer can slice it off. So yes, so when this setup is implemented, total conversions can be sliced by data setting. Now taking another example, whereby we have the media by key, we have date, we have clicks, impressions, media, cost, and over here we have media by tactic and video size. This example, I was talking of, I guess, the first day or second day with someone from here in the team that we have the media by keys. But now what we want is to have additional dimensions in my data so that we can slice the measurements with those additional dimensions of tactic and media by size. Correct. So data set as your actual data alongside media by key, and then data set B has its additional dimensions named tactic and size. So you do a parent-child. If these two streams are kept separately, never can we slice the measurements. Definitely so. Once we do it, what our intention is to have the media by name tactic and media by size. Slice our measurements, clicks, impressions and media cost, right? So that gets done. So yeah, we have seen how we do parent-child, and it is the old way, old slide of parent-child, so don't bother about it. Apply parent-child relationship, and always I've told you the child is something where we need to edit and put the parent update entities attributes when the change has to be updated in order to open up the entity keys from data stream A and allowing data stream B to its existing media by size. We need to check the update entity attributes when they change in data streaming. Okay, we have the So what happens is what we are doing is classification. Data streams needs to have the entity key in the data stream alongside its attributes. That's our goal, and oh yeah, this is important as well, that a parent can be like, a data stream can be a parent of multiple child streams. Okay, so when we say that multiple child, what it means, so wherever we see that, this is my parent, which is applicable to multiple child streams. We can have the parent as parent to be the child of multiple data streams. How, let's talk of this. Let's say we have 3 data streams which we need to align, and what we do is we will do this as part of a re-immersion. So from data stream A, we take the attributes. From data stream B, we take the dimensions, and from data stream 3, we take the dimensions even, and then we create a single parent stream. And then if I do a parent child with like in a single parent and all these 3 children under it, what happens is data from like, data from 1, 2 or 3 data streams can refer the single parent, and it can act as a classification for them so that they can show the data accurately. We will do an example maybe when we are doing the immersion over here. Cool. So we have done live implementation of parent-child. Anyways, like you can check that. So basically this is a conversion tag and display data setup. So that's your campaign, key campaign category, placement and placement size. So it has the full hierarchy, whereas the other one has only campaign key, placement IDs and total conversions. So total conversions need to be so. So basically your display data, which has the full hierarchy, becomes a period, and the child is one which doesn't have the full hierarchy. And what you do is, first is like, what they are doing is they're verifying the relationships between placement ID at campaign ID, placement ID and campaigns, and placement size and campaign ID and campaign category. Why they are doing it? Because they want to make sure that hardware data classification methodologies. Before I go to the PBT, let me take you through the Harmonization Center. Do you want to see the Harmonization Center first? Let's do something. Let's learn data classifications, patterns, and harmonized dimensions. And then what we will do is we will go back to Harmonization Center and see like what is harmonized dimension, trying to show in a holistic view which we want to see. We will do it at last. That will be better. So what is data classification, and why do you need data classification as a part of your process? Data classification is basically sorting and categorizing your data into various types, forms, or any other distinct class. Data classification enables data classification of data according to the data set requirements for various business and personal objectives. For example, classifying campaigns. So I'm sure you guys, This is very self-explanatory, and you guys have seen what is data classification in your day-to-day work as well, whereby you get a set of data. What you do is you go ahead and you receive a source of truth. When I say source of truth, it's nothing but the various classification sheets or the taxonomy sheets or what else you receive. You receive for various fiscal years, for various months, years. You receive the classification sheet that should hold good. So what is classification? Classification is nothing but separating or pocketing your data so that it makes sense to us. So if today, tomorrow, I have a data which is in my campaign name or media by name, and I see it like you know the delimiters. So that's how data classification works, by bucketing your data into the various buckets, which are very essential for us and which we want to see as part of the process. So data classification helps in separating your data and also categorizing your data. So when I say separating your data, your media by your campaign name can be there with delimiters, like underscores or pipes or whatever hyphen. And then that doesn't make sense to us. So what we do is we go ahead and look for this S or T source truth, whereby we know that you know what. The second position after delimiter is country. Third position is country code. Fourth position is device type, so on and so forth. So the classifying this data and bucketing them is called data classification, so that all these values after delimiters and stuff that makes sense to us. That makes not only sense, but also that helps us with the various harmonized dimensions that we receive, or harmonized dimensions or calculated dimensions that we receive. So that we can go ahead and use our dimensions with respect to the measurements, and they do help us make more sense. So, having said that, classifying campaigns by advertisers who are running them is pretty much something that we have seen. We have advertiser column in our search data. We have advertiser column in our display data as well, DFA. So what do we see? We see that the campaigns have many names. Can someone tell me how a search campaign? What is the hierarchy of a campaign from account till created? Campaign and that ad group keywords come separately in ads. Correct? So yeah. So as you mentioned, we have a count, we have the various campaigns, ad groups, and then we have the various keywords and ads. So this entire hierarchy is essential. While you create your campaigns or while you segregate your campaigns, and just to take a step back, why do we bifurcate things into separate campaigns and then separate ad groups? If you consider an e-commerce business, you will find that there are multiple categories that come in. So you have shoes, you have clothing, you have electronics, you have whatnot. So you have decoratives, you have gifting items. So when these everything come into Datorama, when all these things a client brings in and you being an agency, you want to categorize it. So first thing is you want to separate out all the lobbies or line of businesses and then create campaigns accordingly. So why do we need to segregate campaigns? Because we can keep everything under one campaign, right? But we do want to track the campaign performances. We want to track how the campaign performs, and that's why we classify the entire data. Then why do we do it in various ad groups? Because under each category we have various subcategories, right? So if it is a footwear, if it is my category, then I have the various ad groups which deal with flip-flops, with party wear shoes, with ethnic shoes and all those things, right? So all these are the separate ad groups that remains beneath them, and they have the separate creatives even, right? So these are the separate things that come under the separate buckets. And now coming a step forward again. So then when you have segregated campaigns and you want to roll it up to your advertiser, there comes your data classifications in place. So campaigns can be of many names, but if I want to roll it up to the advertiser level, you will see that advertiser will be like, there can be 200 campaigns, but your advertiser is the same, right? Or advertiser can be maximum of 2 or 3 advertisers that you have. So this is a campaign advertiser relationship that we are trying to classify. But you will see the various types of classification that you need to do in your life and roll it up to a separate entity or whatever. The other day we saw with parent-child, we saw that you have. No, not with parent-child. I guess it was with calculated dimensions or no calculated dimensions, I believe, whereby you have the various channels, various sources of data, Google AdWords and Yahoo, Bing, Twitter, etc. And what you did is you rolled it up to if it is a Yahoo, if it is a Bing, if it is a Google Ads, then roll it up as Google search, and then if it is a Twitter, Facebook, etc. roll it up to social. So we saw these, right? We saw these kind of rolling ups happening throughout, and we saw how we are categorizing our data, and data classification will also help you do that. And all these are harmonization techniques, calculated dimensions, measurements, parent, child. You will see that there are overlapping features in each of these harmonization tools. You might think that, hey, why do we have these many harmonizations if there are overlapping features? But then overlapping features doesn't mean that they could have omitted one feature because you won't find. You will find different scenarios in the same case where you need to use the 2 different types of harmonization. Maybe. So, in case even you feel that there are overlapping features between 2 or 3 harmonizations that are available with Datorama, hold back to your seat, because you are going to face situations whereby all these individual sources, individual harmonization techniques come as a separate, as a silo, as a separate case all together, and they come to help you. So keep in mind, whichever case comes in, try to analyze what type of harmonization am I going to use and act accordingly. Maybe somewhere you need a parent-child, maybe somewhere you need a calculated dimension, maybe somewhere you need a pattern, somewhere you need a classification to be done, so on and so forth. But crux of the story remains the same. The purpose is to harmonize our data completely and correctly and accurately and take it forward from there. So that's how our data harmonization techniques are classified in Datorama. When I say that, what I mean is this is how the structure, this is the content of Datoramas. Harmonization. So if I start from the left, we will have calculated dimensions. I should have kept calculated measurements in there as well because that is a major harmonization. And we have learned logical conditions where we have to use logical conditions to harmonize, and then the transformation rules. Transformation rules will take it up. It's a very small topic, so let me cover the grave topics first and then tomorrow. Once we are in tomorrow, we will do all these small topics and we will see how it works. Coming to classification sheets. Lookup is there, of course, but parent-child data fusion, these days data fusion is a bit redundant, having patterns and classification at least. So let's not go in there and let's not. But I'll take up data fusion. Maybe that is another small topic. It's nothing but merging your data and we'll take it. But the grave ones are parent, child data classification patterns and then finally remerging. These are very important topics, along with calculated dimensions and measurements and logical conditions. So these are some of the very important topics that all these are present in the system to provide you with correct and accurate data. But you need to know how to use, where to use, why to use these in separate cases. So that's how structurally it looks like. And before we go off to patterns, we will start with patterns. But let's see a slide on data classification. Basically the option data classification, not the theoretically data classification. We now know that what is theoretically data classification is, but as an option of harmonization, data classification is present as a tab in Datorama. What we do is data classification allows us to classify our data without using a single line of code. Correct. Now, if it is, and all these things that we will learn is with respect to dimensions. Okay, nothing to do with measurements. So, in the earlier slide, we didn't keep calculated measurement because all the factors that you see over there are pertaining to the dimensions and not measurements. Calculated measurement. Why I said it should be there? Because it is also an important tool, but that's for measurements. Rest of all these things are for dimensions, right? So the option data classification that we have in Datorama allows us to classify our data without using a single line of code. This is the most important one. Previously we saw while rolling up our data, we used if function. First we saw extract function. We saw like the count function, distinct count function, and then we saw the if functions. So when we were trying to do a roll up, in that case, what we used was if this, then do this, if this is this, then do this, and then finally an else statement to support everything. But so someone, by the way, when I'm here, let me tell that the code that we use in Datorama is Java, the format that you see. So always align to the Java syntax whenever you're writing your formulas. So data classification allows you to classify your data without using a single line of code, empowering you to easily accomplish tasks that would have previously been done through classification tools like calculated dimensions or VLA or CoOP. So for example, if you need to classify your data by subject area, news, boards, etc., just upload a classification file and you're set to go. A client provides with a separate classification file where each row is assigned to a classification. I guess you guys are used to it, to receive the classification sheets from clients whereby you're bucketed. So data classification basically helps us to do this without using any lines of code. Coming to patterns. Patterns allow the user to extract various information from an entity without using a single line of code. This is basically the extract function that we had used. It is an option which helps you as an extract function, and you don't need to write any form of codes or define any variables or do all sorts of things, because that's a feature which Datorama provides us with, which helps us identify the various buckets and classify them accordingly. So, suppose you have this pattern over here at Toyota Highlander. So from the above campaign name, the naming convention can be now divided into the 4 attributes of car name, car category, promotion name, and site. So we can classify them into these buckets and take it forward from there. Cool, let's go to Datorama and let's see more about patterns and let's see how it works. Okay, so what are patterns and where do you get patterns? Patterns are present in your connect and mix, and from there you go to harmonization center, and from there you go to patterns. So as we discussed what is a pattern. Pattern is also used to bucket our data into several separate buckets so that it's easy for us to refer to our harmonized dimensions and create them as well and segregate our data. So why is the need of patterns when we had calculated dimensions? Let's see when the situation comes. So whenever you see an overlapping thing in a separate tool altogether, just think yourself that what is that feature that this option brings, which is an optimization over the earlier one. So the earlier one may have had the feature, but then this option that is new, the new option that has come up, that is basically something which is that this is new and this is enhanced in some ways. Think of a situation whereby you have 50 data streams and all these 50 data streams need to be classified. Let's consider this thing. Say, suppose all these 50 data streams have respective media by keys and you are not sure even that data. For some it comes from media by, for some it comes from campaign. And somewhere it's the 4th position which gives me site name somewhere. It is 2nd position that gives me site name. Somewhere it gives me, there are 3 positions that give me site name. And then there are data sets whereby we have the same data site name coming from the campaign name, whereas for the other data sets, it was coming from the media buy. Now think from perspective of a calculated dimension which uses logical functions. Think for 100 data streams, how many formulas you need to write. First thing is you need to write formulas for these data streams, and how many formulas you need to write if else, so that you reach at a condition like this, you reach at a solution which is backed by your formulas. So now you have classified your 100 different campaigns. Correct. Now just think you have used all those calculated dimensions in your visualization, and you know the rest is history forever and ever. Because anytime you want to change any filters, you want to toggle between any dates or anything, your Datorama crashes miserably. First, your widgets crash, and sometimes what happens is by crashing and by its huge right to calculate so much on a single slide, so the load time increases and sometimes the widgets fail. Or sometimes, waiting for a good amount of time, it loads up, but that is not a very good customer experience. Even correct. Now always think from perspective of scalable. So it is today you have 2 data sets, maybe tomorrow you will have 200 or 2000 in. So is writing if else formulas in mapping or by calculated dimensions at all scalable at all? We can do something about it. So there comes patterns. Patterns tends to find a similar pattern in your data, and it tries to classify data accordingly. So when a data set comes in a certain format, what it does is it classifies it, but without any hindrance of codes, so that we don't see those type of redundancies when we are seeing the widgets and visualizations. So pattern has a pattern name. It has a source dimension. It has a filter. What are the source dimensions? Source dimension is nothing but a dimension that you need to classify. But your pattern looks for a pattern in your data. If it is single type of, if your taxonomy is cool, what pattern does is it classifies it immediately. If your taxonomy is not cool, what it does is it will classify it. Definitely it is meant to classify, but it will classify everything or nothing. How? Everything or nothing? We will see. So any dimension that you want to classify for us yourself you can do it. There are filters which you can use, like data source filters and data stream filters. And you can write a pattern description to know that what kind of pattern it was. So now let's see 3 separate data sets, which will be eventually data streams which contain data, and how are the things different from one another. First data set, which contains day placement ID placement name. So placement name basically consists of the publisher that you see in the first day limit of publisher. Then we have something, I guess it's country, and then we have, let's consider this to be country. This is country. We have US, and then we have device, and then we have the payment type, and subsequently we have the impression, clicks and media cost. So over here in this data set, we see that we get information of different types from the placement name, and this placement name is basically our entity over here from where we are getting our data. Coming to this data set, we see that we get same type of information. We have POS, we have device, we have size, we have country, we have the publisher from different campaign keys and campaign names. So what happens? We see that the two entities are different in different data sets, but they are throwing up with information which is almost common and which is important for us. And then let's look at the third data set. Over here, what we see is campaign key and campaign name gives us the information, but over here we see a difference in naming convention. Right over in the last few things. We had the payment type at the last, but when we go to the data set, we see that payment type has come to the first, then publisher, then country, then size, and then device. So the three situations. So these three data sets are unique in some ways that they are giving us information. Yes, but the first two data sets are giving us information. One is giving us information from media buy. One is giving us information from campaign side, and one is giving us information from campaign again. But its naming convention is different. Correct. So we have two scenarios, one whereby our naming convention is different. Second, where our entities are different. Correct. So now think, if this kind of a scenario comes from hundreds and thousands of data streams, will you be going ahead and writing formulas for them? Will you be taking resort of formulas? If you take, then how much of formulas you need to write? Second, is it scalable? Think one of these value changes from the campaign names. Now you keep on editing your formulas for all these, so it is not scalable. It is not something that we recommend as well. So there comes patterns to our resort. So what we did, we basically went ahead and mapped these three data sets as we do in Data Lab, right? So basically these three data sets that you see, simple mapping, nothing complicated in here. Date media by key media by name impressions, clicks and media cost, and for the other one it is campaign right. For the other one, we have the data coming from campaign and it has campaign only so day, campaign key, campaign name, impression clicks and media cost. And for the third data set that we have, there also we have campaign, so we have mapped the campaigns. Now that we know that data is coming from the various data sets together. So what we will do is we will go ahead and create a pattern for ourselves. From Connect and Mix, we go to Harmonization Center. From Harmonization Center, we go to Patterns. Now let us check how we create a pattern. We do an Add New. What we do is we give a pattern name. Say suppose we give it as test_pattern. We select the dimension, what we need to for the first data set that we have. We want to classify it as media by name, right? So it gives us all the types of media by names that are present in the workspace, right? So it gives us all the types of media by names that are present in my workspace, but I need one view of it, right? Now think this is a training workspace, so it does not have much of the options present and we have only two words and the other one. But just try to think. So whatever I show you with one data stream or two data stream, Just think they are multiplied by 100, like if I show you 2 multiplied by 50. So always try to think sorry, very sorry, very sorry, very sorry. So always try to think you know the data from the perspective of 100 data streams together. So when you have 100 data streams together, just try to think how many media by names will you have for yourself, and will you be going ahead and choosing from there? No. So what do is you go to add filter, whereby you have two options of data sources and data streams. So go ahead and choose your data stream which is relevant. That was my media by data stream. So if I select it over here, do a done. Now I have the entire set of, so I had my placements names in this format and I have it over here. So what I can do is I can select one of these. So this basically shows me the options, the various options available for me to classify my data when I choose this filter. And if I do not apply, data at each delimiter level gets classified into the various buckets. Right? So can we select multiple media by names? Can we select multiple media by line items? You select only one. You can select only one. So there is a pattern. Whenever your pattern aligns with all the other media by options in your data set, you will have only one thing to select. Okay, now there are two types, so all the other ones, right? If we create one pattern by selecting one of the media by names, then automatically which applies to all the other media by names. It does. So there are two types of setups. One is a manual setup and one is an automated setup. So if you go ahead and check your manual, so what you see is this entire thing has come in. Now what you need to do is you need to add a position. It shows a legal pattern because we haven't defined anything. But you need to go on and add this as a manual setup, and you need to do this. But that is something which is a very hectic task. So what we will do is, we won't be doing that. What we do is we choose this and we have it all classified. Okay, and here we see that our data is structure compliant. So there is a toggle box above which will tell you, like, if your data is not structure compliant, then it will. I'll show you what happens when it is not structure compliant. Say, suppose all these media that come in, they come in different shapes and different delimited values. Some may be, 5 words long, some contains only 2 information, so on and so forth. Pattern is not recommended at that point of time. But then you can create multiple patterns, or you can toggle, switch this off so that it takes everything in under the limiters. I'll show you how it works. Let's see this first. So now over here we know that. My data is delimited by first is my columns came in, whatever is there. Second is the delimiters. Now over here I have an uniform set of delimiters, that is, it's visible, right? It's not pretty. I guess now it is better now. So see, it is all separated by underscores, right? So when it is separated by underscores, what we do is over here after one position, there is a small box which tells us that how is your data in position 1 and 2 delimited. Now here we had underscores. But say, suppose tomorrow you get a data where the first delimiter is underscore and the second delimiter is a hyphen. Third delimiter is again a hyphen. So third delimiter is a slash and fourth delimiter is a underscore again. So what you can do is pattern gives you this flexibility to define the delimiters in various boxes. Say, suppose it's a slash, and then after that say, suppose it's a hyphen, and then if it is so, if your data is structured like that, then you can go ahead and change these delimiters in here as well. And what it will help is it will help you to classify your data with whatever like a delimiter comes in place. Now the third is you can give names for this. Don't think these names are like Don't consider these names because these names are coming because I have used these names, but you won't be. Whenever you are creating a new pattern, you won't be getting any names over here. So just try to, and also remember, once you have delimited any of these columns in here, these individual columns become a separate dimension. Now, if you put this, say suppose if you want these to be the separate harmonized dimensions to be used for your visualizations. So you need to always maintain a uniform naming convention. So what I tend to follow is a naming convention which has a pattern in the brackets because I'm extracting them from patterns. Or else what happens is if you create a country dimension, it becomes very difficult when you are trying to bring it for your visual because there is a country that comes from the native source and there is a country that comes from a calculated dimension and there is something that comes in from your pattern. So will it be a problem in searching? Definitely yes. Will it be a problem? Is it a very big problem? Definitely no, because what you need to do is from all these things, you need to have a very good eyesight and you have to have a very good memory for yourself to know that. Tomorrow, if there are 8 to 9 country columns in my workspace, which among them is my pattern harmonized dimension? Rather than that, if I do a proper naming convention from the start, and naming convention is a very important factor in data analytics and reporting because once you have named your data correctly, tomorrow, if anything goes for a miss as well, you know that where to find your data, by what name and how to use it. So I tend to create these dimensions based on the harmonization I'm using and I put them in brackets. So you can go ahead and name it as anything what you want. I have named it as publisher. You can go ahead and name it as whatever like. Say suppose publisher, only publisher, and you can name it as pattern. Extract button. The extract button basically helps me with extracting the data and maybe I want to extract this as well and this as well. So what will happen is these will get extracted. This won't be the other day. I guess I was telling to someone's query that while in patterns it's not necessary that you have to classify, you have to have every position as your harmonized dimension. You can stop the extract from happening as well, but this won't be deleted. This you cannot go ahead and delete it off because what happens is your entire data structure gets defined. Your data model gets hampered. So let it be here, like let this toggle be at and off so it won't get extracted. So that's how you create one. Now let me discard this pattern and go back to the patterns that we already have at least. Okay, so we have the media by pattern. That we have seen, right? This is my media by pattern going ahead. This is my campaign pattern. This is the third pattern. So there I have my media by names. Now let's understand what is our purpose. So always before doing anything, we need to understand our purpose. So this I classify, right? I classify the first element to be medium, second to be country, third to be dimension. So add dimensions. This is not any other dimension. This is add dimensions because you see placement size in there. We have class named this position as device and the fifth as mode of payment. So now let's understand what is our next goal. Now we will go and classify the campaign ones because my second data set was campaign data set and I know that things are coming in from campaign entity. Correct? So what we do is we go to the campaign. We create another pattern. We edit the filter to be as campaign pattern and we see that we have these options. We select one and we name them. Now that's what I was saying. What is our aim? Our aim is to classify the components of all these, the components of campaign name column and media by name common column. Find the common factors, merge them together and see the data accordingly. Right. That is our goal. Our goal is to have country code classified by the media by data stream, campaign data stream and as well the other campaign data stream which has a different naming convention. Why are we doing it? Because we have separate scenarios in here. We have the info coming from media buy. If all the three had coming from media buy, we didn't need a single pattern. Would have worked for us. But as we have similar data coming from different places, we are creating separate data streams, which calls for same names. Right? Because you are separating medium. If I consider medium or if I consider dimensions, the one which is basically nothing but placement size. Now, placement size comes from media by pattern. Placement size comes from campaign pattern. But when you want to see them as a set, as a harmonized dimension, you want to see dimensions pattern from both media by pattern and the campaign pattern. Right. So in order to do that, why I'm reiterating it is you need to give the same name so that tomorrow when both these harmonized dimensions get created from the two data streams, they don't have two different names because then you cannot merge them into a single column. Correct. So that's how we have named again as medium, country, dimensions, device and more. Let's go to the third pattern. In my third pattern as well, data was coming from the C I've named. I've taken the data stream filter. In my third pattern as well, things were coming in, but what's the difference? The difference was that there was a naming convention. Difference. Correct. We had the first position in the pattern to be mode of payment. Right. So not only does pattern help us with identifying the common factors from different entities in different data streams, but also it helps us to merge the like. Merge the two. Extracted harmonized dimensions even if they come in separate. In my delimiter, it may be somewhere in the last, somewhere in the middle, or at the first. That shouldn't be a problem for us because we now know that we will create patterns. We will delimit you and we will name you the same so that wherever in my media by your campaign you are, I can extract you and I can make your harmonized dimension by culminating with the other harmonized dimensions in my data. Right. So over here what happens is payment comes in first position. So I have made the mode over here, then medium, then country, then dimensions, and then right. So now I have successfully created all the 3 patterns for myself, and over here I can see that there are 5 number of positions for each pattern. It may be 4, it may be 3, because in some, maybe all the options are not coming in when you are trying to classify, but then the needed ones are coming, right? So that's how you create them. And now let's look at now we have the 5 positions classified. See, when we go to harmonized dimensions, previously it was empty. If you remember, 2 or 3 sessions back, we once came in here and we said that the harmonized dimensions are empty because we don't have any kind of patterns making harmonized dimension. If you remember, good. If you don't remember, then that's fine as well. So you see that now, once we have created all these, we have done these patterns. So if you go to this harmonized dimensions, if you go to this medium pattern, maybe, and you do a double click, what you will see is this pattern. Sorry, this dimension, this harmonized dimension, medium pattern. This basically is coming from 2 places. It is coming from the first position of media buy and it's coming from first position of campaign for this pattern name and second position of campaign from one pattern name. So 2 out of 5 and 1 out of 5 and then in media by name is coming from the first position. So that makes your life easy as well once because you know that it is classified properly and then you can go and check how your data looks like after classification in a visual. So now each of these medium pattern, country code pattern, device pattern dimension and more, all these have become separate columns. Previously, these were coming as delimited factors of media by your campaign names, right? Now, they are individual dimensions and you can see the data for for all these individual dimensions. If you want to, you can go ahead and now use them as part of your graphs, maybe. And you can do like bar graph or you can do an area graph or whatever options that you have for yourself. You can venture all these things and you can see how the data makes sense to you and so on. You can just check for yourself. Check for yourselves how things are working for you or not. Right. So now all these things have become individual dimensions and individual things, and it basically can be used as part of the table as well as part of any of your visuals that you want to where you think it makes sense. So that's about patterns. Now we were talking of a situation, right, whereby my data is not structure compliant. Now you see that what happens is when your data is not structure compliant or your media by names are not structure compliant, what pattern does is it doesn't allow things to happen. So maybe there is this one campaign that is getting classified because it is structurally compliant, but then nothing else is getting done. So in this position, if you switch off the structure compliant option, what happens is for all your media by names for this data stream. This is also a helpful way why I tell you. What happens is all the positions basically get classified. Now again, all the positions. When we say so, you see that then also there are problems because see, the underscores are coming in somewhere and all the other things are like, somehow it's getting done or something. So for a non-structure compliant data, it is not something which is very much recommended. Rather, what we can do is Next, let's check us what is data classification and how data classification helps us. And then we will see how data classification and pattern together hand in hand can resolve these problems that we see in our media by names. But generally, if you see, generally the taxonomies should be correct, right? Generally, if we have a taxonomy governance team in our agency, or if we have a taxonomy that is defined from the client's end, and when the tagging team is working with generating the campaigns and with generating the various campaign constructions, they should have abide by something called a campaign, campaign naming convention. But yes, but errors happen, or maybe transitional phase happens whereby one guy has worked with something and the other person has come in as a to fulfill the position and all these things. So at that point of time, these errors may happen. And then comes hand-based data classification, which basically by holding hand the pattern can resolve these kind of situations. So non-tech but non-compliant data basically doesn't help us much. So yeah, for non-taxonomy compliant data, this is not the right way to move ahead. But when we are sure that your campaign or media by something that is classified, else what happens is this is a very more screwed out data. But if there is something that happens it comes as not valid for some of the places. So if it is there are suppose 3 types of campaigns in my data. So maybe one type gets classified. I know that there are other 2 types. We can go and create 2 separate data 2 separate patterns for ourselves by identifying the 3 ways. But over here we have a long list. I just wanted to show what happens is when your data is not structure compliant and when you toggle it off, how it tends to classify the various positions that it gets for all the campaigns. Okay, so clear? I guess we are. We are good with this. We are good with patterns. If we are, then what we will do is we will move towards data classification. And finally, do not forget to like, share and subscribe to our channel.